Imagine for a moment that you possess the ability to travel backward through time, stepping into a machine that bends the very fabric of causality and deposits you in the past, perhaps 50 years ago, to a moment when your grandfather was still a young man before he ever met your grandmother. In this scenario, you find yourself face to face with him, and consumed by some unknowable impulse or perhaps driven by a desire to prevent your own existence, you decide to prevent him from living. You raise your hand, and in that instant, your grandfather ceases to exist, erased from the timeline before he could ever father the parent who would eventually create you. The paradox emerges immediately from this action because if your grandfather never lived, then your parent was never born, which means you were never born either, and therefore you could never have traveled back in time to eliminate him in the first place. Yet if you never traveled back, then your grandfather remains alive, which means you were born, which means you did travel back, which means you killed him, and the cycle perpetuates endlessly without resolution. The mechanism that makes this paradox so conceptually troubling operates on a fundamental level of linear causality, the assumption that causes must precede effects in an unbroken chain of events flowing from past to future. We construct our entire understanding of reality upon this principle, believing that time moves in one direction and that actions create consequences that ripple forward into the future. When we confront a scenario where an effect appears to negate its own cause, our logical frameworks collapse entirely, unable to accommodate the contradiction. The grandfather paradox has persisted for decades as a thought experiment precisely because it highlights something deeply unsettling about our assumptions regarding time and existence. Despite the fundamental illogic of the scenario, we continue to discuss it, write about it, and embed it within our stories and philosophical discussions, suggesting perhaps that some part of us recognizes that our understanding of causality may be incomplete or even fundamentally flawed in ways we have not yet fully acknowledged. Consider the possibility that the universe itself might possess an inherent resistance to paradox, a kind of temporal immune system that prevents contradictions from arising, whether through quantum branching into alternate timelines, subtle alterations in causality that prevent the lethal action from occurring, or some other mechanism we have yet to discover. In this light, the grandfather paradox becomes not merely a logical puzzle, but a window into the fundamental architecture of reality itself. Perhaps the most intriguing aspect of this temporal immune system is that it forces us to reconsider whether free will operates differently in the past than in the present, suggesting that the very act of traveling backward might strip us of our agency, making it impossible to alter events no matter how desperately we might try. In this interpretation, the grandfather paradox dissolves not through mystical intervention, but through the simple truth that the past has already crystallized into immutable fact, and any time traveler remains forever bound by the constraints of what has already occurred. Imagine a composer sitting alone in a modest apartment, struggling to write an original symphony, when suddenly a figure materializes before them from the future, holding a manuscript of that exact symphony, completed and perfected, which the composer then copies and publishes as their own work. And decades later, when the composer finally travels back in time, they hand that same manuscript to their younger self, creating an infinite loop where the symphony exists, but was never actually created by anyone, existing only because it exists. Information and art emerging from absolute nothingness with no origin point whatsoever. The Bootstrap Paradox presents us with this troubling logical knot where information appears to violate the fundamental law of conservation, suggesting that under certain time travel conditions, knowledge and creative works could circulate through causality without ever being generated from a source, a phenomenon named after the impossible childhood fantasy of pulling oneself up by one's own bootstraps. And the mechanism at work here challenges our deepest assumptions about how information must come into existence. In our normal experience, all information originates somewhere, emerging from a mind, a natural process, or an intentional act of creation. Yet the Bootstrap Paradox asks us to contemplate a universe where information could exist in a closed causal loop, traveling backward and forward through time indefinitely without requiring any initial creation event. And this doesn't violate entropy or conservation of energy in the traditional sense. Because information itself might be treated differently by the laws of physics, somehow existing outside the normal requirement for origination. What makes this paradox particularly unsettling is that we have normalized countless versions of it in our culture without recognizing them as such, passing down stories and songs through generations where the original creator remains lost to history, treating mythology as inherited truth, rather than asking whether these cultural artifacts emerged from someone's deliberate invention at some point. And we accept this ambiguity about origins so readily that we rarely examine the philosophical vertigo it should inspire, instead choosing to believe that even if we cannot locate the creator, one must have existed somewhere. Yet the Bootstrap Paradox suggests this comfortable assumption might not be guaranteed. And so we continue circulating information through our civilization, copying, transmitting, and repeating knowledge without ever truly questioning whether infinite regress might be more fundamental to reality than we care to contemplate. Perhaps this is why we find ourselves so drawn to origin stories and creation myths. They serve as psychological anchors against the vertigo of infinite regress, yet their very persistence across cultures without clear authorship might itself be evidence that some information has always simply existed in the collective human consciousness, passed down so many times that the distinction between discovery and invention has become meaninglessly blurred. And perhaps this is the universe's way of telling us that the Bootstrap Paradox is not a logical error requiring resolution, but rather a fundamental feature of how information and consciousness interact with time, a feature we are only beginning to recognize because we have spent so long searching for origins in places where none may ever be found. Imagine a footrace between Achilles, the swiftest warrior in all of ancient Greece, and a tortoise, one of nature's slowest creatures. Yet this tortoise is given a head start, perhaps 100 meters down the road, and both begin moving forward at constant speeds through an endless landscape. Achilles runs at 10 times the speed of the tortoise, yet here is where the paradox emerges with its curious logic. Before Achilles can overtake the tortoise, he must first reach the point where the tortoise started, but by the time he arrives at that location, the tortoise has moved forward to a new position, and so Achilles must then close that new gap. Yet during the time it takes him to reach this second position, the tortoise has again moved forward by some amount, and this process repeats infinitely, creating an infinite series of smaller and smaller intervals that Achilles must traverse before he can finally pass his slow-moving rival. The paradox suggests that Achilles, despite his superior speed, can never actually overtake the tortoise because he must complete an infinite number of steps to do so, and infinity, by its very nature, seems to stretch on forever without end or completion. This logical puzzle haunted ancient philosophers like Zeno of Elea, who crafted it specifically to challenge the concept of motion and the divisibility of space and time, suggesting that perhaps movement itself is an illusion and that we cannot truly traverse distances because we must always pass through an infinite number of intermediate points first. The mechanism at work here involves our intuitive fear of infinity combined with our uncertain grasp of how mathematics actually handles infinite series. Because while our minds rebel at the idea of completing infinitely many tasks, mathematicians and physicists eventually demonstrated that infinite series can sum to finite values, meaning that Achilles does indeed overtake the tortoise in a perfectly finite amount of time, despite needing to complete infinitely many steps to do so. Yet despite this mathematical resolution existing for centuries, despite our clear understanding that motion is real and constant, despite watching people and objects move every single day without any apparent paradox or hesitation, we still find something deeply troubling about this ancient thought experiment, and we still feel a residual unease when contemplating infinite division, as though some part of our consciousness insists that infinity must prevent completion. That completion must resist infinity, and that perhaps there is something fundamentally unknowable about motion itself that lingers just beyond our complete comprehension. This unease may persist because the paradox, though mathematically resolved, still touches something true about the nature of infinity itself, that our minds evolved to handle finite problems in finite time, and asking us to embrace infinity as both real and completable asks us to think in ways fundamentally alien to our evolutionary inheritance. Perhaps Zeno's true genius was not in creating an unsolvable puzzle, but in revealing the deep conceptual gap between how we experience motion and how the universe actually operates. Imagine two twins standing together on Earth, identical in every way, sharing the same moment in time, the same age, the same biological clock ticking forward at precisely the same rate. Now imagine one of them boards a spacecraft and travels through space at nearly the speed of light, journeying to a distant star and back again, while the other remains at home, living out their days under the familiar sky. According to Einstein's theory of special relativity, Time itself moves differently depending on how fast you're moving through space. And so when the traveling twin finally returns home, after what feels to them like only a few years of subjective experience, they will discover that decades or even centuries have passed on Earth, and their stationary sibling will have aged dramatically while they remain relatively young and unchanged. This is not a matter of perspective or perception, but rather a genuine physical reality that has been confirmed through countless experiments with atomic clocks placed on fast-moving aircraft, demonstrating that time literally passes at different rates for objects in relative motion. The psychological mechanism that makes this paradox so deeply unsettling is rooted in our intuitive understanding of time as absolute and universal, as something that flows at the same pace for everyone regardless of circumstance, an assumption so fundamental to human experience that we rarely question it. We are accustomed to thinking of time as a river that carries us all along at identical speed, indifferent to our location or velocity, and so the suggestion that time is actually malleable, that it can stretch and compress based on the laws of physics, contradicts everything our bodies and minds have learned from a lifetime of synchronized existence with others. The paradox has persisted in popular consciousness not because physicists have failed to explain it, but rather because the explanation itself reveals something so profoundly alien about reality that we struggle to truly integrate it into our worldview. And so we continue to live as though time is fixed and universal, even as we acknowledge intellectually that it is not, creating a kind of normalized cognitive dissonance where we accept the mathematics while remaining emotionally unconvinced of its truth. This gap between intellectual acceptance and intuitive belief mirrors humanity's broader struggle with counterintuitive truths. We can recite the facts of quantum mechanics or cosmological expansion without truly feeling their implications in our bones. Yet the twin paradox remains uniquely poignant because it speaks directly to time itself, that most intimate dimension of human consciousness, the very substrate through which we experience love, loss, and mortality, making it perhaps the most personally threatening of all scientific revelations. When we contemplate a twin separated from us by relativistic speeds, we are forced to confront the possibility that time itself is not democratic, that the universe does not guarantee equal experience to all observers, and in that recognition lies both the terror and the wonder of modern physics, a humbling reminder that our subjective sense of duration is merely a local perspective on a cosmos far stranger than our ancestors ever imagined. Imagine an arrow in flight, suspended in the air between a bow and a distant target, moving through space at considerable velocity. At any single instant, any infinitesimally small slice of time, the arrow occupies a specific position in space, and at that precise moment it is neither moving forward nor backward, it simply exists at a particular location. If we examine the arrow at one instant, it is stationary at that point, occupying a space equal to its own length. In the next instant, it occupies a different space, also stationary in that moment, and in the instant after that, it remains motionless once again. This is the paradox that troubled the ancient philosopher Zeno of Elea 25 centuries ago. If an arrow is always stationary at every instant of time, always occupying a fixed position with no movement occurring within that instant, then how does motion actually occur? How can something that is perpetually at rest at every moment manage to move across space? The paradox reveals a fundamental disconnect between how we perceive motion and how motion actually exists at the atomic level of time itself. When we break down any movement into its smallest temporal components, individual moments that cannot be further divided, motion vanishes entirely, replaced only by a series of static positions. The mechanism operating here is the tension between continuous experience and discrete reality, between our intuitive understanding of smooth, flowing movement and the logical impossibility it creates when examined through the lens of instantaneous states. Our consciousness perceives the arrow as smoothly traversing the distance, yet our reason insists that at no individual moment is any motion actually taking place. We have normalized this paradox by simply accepting that motion exists without fully resolving the logical contradiction it presents. Physics has developed mathematical frameworks like calculus that describe motion with precision without ever truly explaining how movement emerges from stillness. We observe arrows reaching targets and athletes crossing finish lines, and we accept these outcomes as proof that motion is real, yet we have never satisfactorily explained the mechanism by which something can be stationary at every instant and still travel through space. The paradox persists in the background of scientific understanding, unresolved and often overlooked, a reminder that the nature of time and motion remains fundamentally mysterious despite our technological sophistication. Perhaps this is why quantum mechanics has revealed that at the smallest scales, particles do not possess definite positions at definite times. Nature itself seems to reject the very premise of Zeno's paradox, suggesting that reality at its foundation operates according to principles far stranger than the classical logic that troubled ancient philosophers. The observer effect in quantum mechanics, the principle that measurement itself alters reality, suggests that perhaps motion cannot exist in the unobserved instant, only emerging into being when we examine it. In this view, Zeno was right that motion is impossible in frozen moments, but wrong to assume those moments exist independently of observation, waiting to be analyzed. Perhaps the arrow itself, like all matter, is not truly solid at all, merely a pattern of probability and energy, a wave of possibility that collapses into a defined trajectory only when reality chooses to look. Imagine standing at a train station where every moment that has ever existed, every moment happening right now, and every moment that will ever exist are all equally real and present simultaneously, laid out like a vast landscape stretching infinitely in all directions. This is the philosophical concept known as the block universe, a framework suggesting that past, present, and future all exist at once in a four-dimensional space-time continuum, neither more nor less real than the others. In this model, time is not a flowing river carrying us from yesterday toward tomorrow, but rather a dimension much like length, width, or height, where all events, your birth, this very moment, your death, the heat-death of the universe, coexist eternally in a static, unchanging block of reality. The mechanism underlying this perspective emerges from how we understand physics and mathematics. Einstein's theory of relativity suggested that time is not universal or absolute, but is woven together with space into a unified fabric, and once something happens in spacetime, it does not cease to exist merely because we have moved past it chronologically. The mathematics of relativity treats past and future symmetrically, with no special privilege given to the present moment. Events in spacetime can be plotted on a four-dimensional graph just as easily as we plot points on a three-dimensional map, and in this mathematical landscape, all points exist with equal ontological weight, regardless of whether we call them past, present, or future. What makes the block universe so psychologically strange is that it directly contradicts our lived experience of time as something that moves, changes, and carries genuine novelty. We feel the present moment as something unique and special, distinctly different from memories of yesterday or anticipations of tomorrow. Yet the block universe insists this distinction is merely a subjective illusion created by the limitations of human consciousness and perception. Despite the logical appeal of this model among physicists and philosophers, we continue to structure our entire existence around the assumption that time flows, that the future is genuinely open and uncertain until it becomes present, and that our choices matter because they determine which potential futures become real. We make plans, form intentions, feel regret about the past, and hope about the future, and we have built moral and legal systems entirely predicated on the belief that causation moves forward through time and that we are responsible agents whose decisions shape what comes next. The block universe persists as a serious philosophical position precisely because the mathematics works and because it resolves certain conceptual puzzles in physics, yet we cannot help but live as if it were false, as if time genuinely flows and the present moment genuinely matters in a way that the distant past and distant future do not. This tension between what we know intellectually and what we experience existentially may be the deepest paradox of human consciousness. We are beings capable of understanding that our sense of temporal flow might be an illusion, yet we remain incapable of truly believing it, and perhaps this very incapacity is itself evidence of something real that the equations have not yet captured. Consider the distant galaxy of Andromeda, which orbits in space approximately 2.5 million light-years away from our own Milky Way, a distance so vast that light itself requires millions of years to traverse the cosmic expanse between us, and yet modern physics suggests that at this very moment, somewhere in the universe, Andromeda and our galaxy are simultaneously colliding, merging together in a catastrophic dance of gravitational forces that will reshape both cosmic structures entirely. And this collision is happening right now, in the present moment that you are experiencing as you listen to these words, even though the light from this collision will not reach Earth for another 4 billion years, meaning that the future event that we predict with mathematical certainty is already occurring in the present, even though we cannot perceive it, cannot witness it, cannot know it has begun. The paradox emerges from our relationship with simultaneity and causation across cosmic distances, where Einstein's theory of relativity permits different observers at different locations to disagree fundamentally about what events are occurring at the same moment in time, making the very concept of a universal present moment dissolve into ambiguity and relativity. Our minds struggle with this because we evolved to perceive a single, unified now that flows uniformly forward, a present moment that is the same for everyone everywhere. And yet physics reveals that this intuition is precisely wrong, that simultaneity is not absolute but relative to the observer's frame of reference, that events billions of light years apart cannot meaningfully be said to occur at the same time in any objective sense. We have rationalized this paradox into our scientific understanding through mathematics and equations, yet we continue to live as though the universe operates according to our subjective sense of a shared present, as though future events do not already exist in some form, as though the distinction between what is happening now and what will happen later remains meaningful, despite having constructed an entire framework of modern physics that suggests otherwise. Revealing how thoroughly we compartmentalize the implications of our own discoveries from the way we experience and navigate moment-by-moment existence. Perhaps this is why we cling so desperately to the illusion of free will and choice, why we experience genuine surprise at outcomes we theoretically knew were determined, why the subjective now feels so vivid and real even as we intellectually acknowledge it is merely our local perspective on a universe where all moments, past, present, and future, exist equally in the fabric of spacetime, eternally written into the geometry of existence. And yet this acceptance of a static, four-dimensional spacetime where all moments coexist eternally does nothing to diminish the felt urgency of our choices in the present, the visceral weight of decisions that feel consequential even if their outcomes are already written into the cosmic structure, suggesting that perhaps the paradox is not meant to be resolved, but rather lived within. As consciousness emerging from a deterministic universe that somehow generates genuine experience of agency and uncertainty despite its own timeless architecture. Consider the peculiar way we experience moments as they unfold around us, where we speak of events as happening in the past, occurring in the present, or waiting in the future. Yet when we examine this framework closely, we find ourselves caught in a logical contradiction that has troubled philosophers for over a century. John McTaggart, an English idealist philosopher, proposed that this temporal ordering system we call the A-series, which divides all moments into past, present, and future, contains within itself a fundamental logical problem that cannot be resolved, and this problem suggests that time, as we conceive of it, does not actually exist in reality. The mechanism of McTaggart's argument rests on a deceptively simple observation. Every event must occupy all three temporal positions simultaneously, for at some point in time every future event becomes present, and then subsequently becomes past, meaning that the same event is both past and future and present, which seems to violate the basic law of non-contradiction, the very foundation of logical thought. We might imagine a wedding that we anticipate next summer, and we say truthfully that it is in the future, yet we also know with certainty that when summer arrives, this same wedding will be present, and years later it will be undeniably past, and McTaggart asked the piercing question of how one event can genuinely possess these mutually exclusive properties unless we introduce some additional temporal dimension to explain the shift, which then requires another dimension to explain that shift, leading to an infinite regress that cannot be satisfied. The psychology behind our persistence in believing in this flawed model of time, despite its logical incoherence, stems from the overwhelming vividness of our subjective experience of temporal flow and the rigid categories our language imposes upon us. For we are so deeply embedded in the sensation of moving from past through present into future that abandoning this framework feels impossible, even when we intellectually recognize its contradictions. We have normalized this paradox so thoroughly that we rarely pause to question whether the temporal distinctions we make in everyday speech about what has happened, what is happening, and what will happen correspond to anything real in the fabric of existence, or whether they are merely useful fictions that our minds have constructed to navigate the world. If we accept McTaggart's conclusion that the A-series is fundamentally incoherent, we are left with the B-series, an alternative framework in which events exist in a static, unchanging order of earlier than and later than, stripped of any genuine passage or flow, suggesting that time might be more like a landscape we survey from outside rather than a river we travel through. This austere vision offers logical coherence at the price of abandoning our most intimate intuition about reality, that the present moment is uniquely real and privileged, that the future remains genuinely open, and that time genuinely passes. Yet perhaps this trade-off reveals something profound, that our cherished experience of temporal passage may be the price of consciousness itself, a necessary illusion that allows us to narrativize our lives and conceive of ourselves as agents moving through time, even if the underlying reality is fundamentally static and atemporal. Consider the present moment, that infinitesimal slice of time you call now, the only moment that is actually happening while all others exist only in memory or anticipation. And yet when you try to measure it, to give it substance and duration, it dissolves into nothing at all, for any duration you assign to the present immediately becomes the past, leaving you with a boundary so thin it cannot be perceived, a mathematical point with no width, no thickness, no measurable span of existence. If the present moment has zero duration, then technically nothing is ever actually happening in the present, since happening requires time to occur within it. Yet somehow you experience the sensation of present experience continuously throughout your waking hours, a direct and undeniable awareness of now that seems to contradict its own non-existence. The mechanism underlying this paradox reveals itself when you examine how consciousness processes time, for your brain does not actually perceive instantaneous moments, but rather constructs a specious present, a temporal window of roughly 2 to 3 seconds during which events feel simultaneous and present to your awareness, a duration that your mind presents to you as the now even though it contains multiple seconds worth of actual time. This means your experience of the present is fundamentally illusory in a precise sense. You believe you are experiencing now in a single instant, but your consciousness is actually synthesizing several seconds of neural activity into a unified feeling of presence, creating what philosophers call the thickness of the present through biological sleight of hand. Yet despite understanding this mechanism, despite knowing that the present either has no duration or an invisible duration manufactured by your brain, you continue to orient your entire existence around this paradoxical moment, making decisions based on what seems to be happening right now, planning your future from a present that technically does not exist, and treating the now as the only moment that truly matters, the only moment you actually live in. Even though it vanishes the instant you try to grasp it. And perhaps this is precisely the point, that you are not meant to grasp the now, that the present's elusiveness is not a flaw in your perception, but rather the essential condition that allows time to move forward at all, that allows you to change and grow and become someone new. For a present moment you could hold and examine would be a present moment frozen, and a frozen present is no present at all but merely another form of the past pretending to stillness. The river does not hold its water and call it present. It flows, and in that flowing becomes itself, and you are the same, not a consciousness observing time from some fixed point outside it, but a process unfolding within duration itself, always already moving toward what comes next, which is perhaps why the present feels like nothing when you examine it directly, because you are looking for a thing when you yourself are the happening. This is why the illusion of the present moment persists even as you understand its impossibility, because you are not separate from time enough to see it clearly, any more than an eye can see itself without a mirror, and the present is the one temporal dimension you cannot observe from outside yourself without ceasing to be the thing that observes. Imagine two observers standing at opposite ends of a moving train, each equipped with a clock that is perfectly synchronized according to their own reference frame, and in the middle of that train, a flash of light is emitted from a lamp positioned exactly equidistant from both observers. In the reference frame of the train itself, both observers see this light reach them at precisely the same moment, confirming what we might call simultaneity, yet to a stationary observer standing on the platform watching this train rush past at significant velocity, the light from that central lamp will reach the observer in front of the train's direction of motion before it reaches the observer behind it. Which means that what appears simultaneous to one observer is demonstrably not simultaneous to another observer, regardless of how carefully the clocks have been synchronized or how precise the measurements become. This phenomenon, known as the relativity of simultaneity, reveals that the very concept of things happening at the same time is not an absolute property of the universe, but rather depends entirely upon the reference frame of the observer doing the measuring, and this is not a matter of perception or of information traveling at different speeds between observers, but but rather reflects a fundamental truth about the structure of spacetime itself. Where time and space are woven together in such a way that there is no universal present moment that all observers everywhere must agree upon. The mechanism underlying this strange property emerges directly from the constancy of the speed of light, combined with the principle that the laws of physics remain the same for all observers moving at constant velocity relative to one another. Because if light always travels at the same speed for every observer regardless of their motion, then the geometry of space and time must bend and stretch in precisely the ways that Einstein described. And simultaneity must necessarily become relative rather than absolute, a consequence that follows as inevitably as shadows follow objects in sunlight. What is perhaps most remarkable about how we have come to accept this relativity of simultaneity is that we have incorporated it so thoroughly into our scientific understanding that we rarely pause to recognize how profoundly it undermines our intuitive sense that time flows uniformly and identically for everyone everywhere. Yet this counterintuitive truth has been verified countless times through experiments with particle accelerators, observations of cosmic ray muons, and precision measurements with atomic clocks on fast-moving aircraft, confirming that what Einstein predicted mathematically is precisely what nature actually does. And we have simply accepted this as part of the fabric of reality, neither surprised nor disturbed by the revelation that simultaneity is not a fundamental feature of existence, but merely a human convention that varies with perspective. The implications extend even further. If simultaneity itself is relative, then the sequence of cause and effect can actually appear reversed to different observers, suggesting that causality itself is not written into the fundamental laws of physics, but rather emerges as a consequence of our particular reference frame and the direction in which entropy increases. A realization that dissolves the boundary between past and future into something far more fluid and interconnected than our everyday experience suggests. Imagine a scenario where someone travels backward through time with the explicit intention of preventing a catastrophic event from ever occurring. Yet every action they take to stop this disaster inadvertently becomes the very cause of the very thing they sought to prevent. And this chain of causality loops back upon itself in such a way that the event was always destined to happen precisely because of their attempt to stop it, creating a closed temporal loop where cause and effect become indistinguishable from one another. Consider the real-world manifestation of this paradox in human behavior and decision-making, where a person becomes so consumed by their fear of a particular outcome that their anxiety-driven actions and choices push them directly toward that feared outcome, making their attempt at prevention the actual architect of their own misfortune. A student terrified of failing an examination becomes so paralyzed by this fear that they cannot study effectively, and this very paralysis guarantees the failure they feared, or a person so convinced that their relationship is doomed begins pulling away emotionally as a protective measure. And this emotional withdrawal becomes the catalyst that actually destroys the relationship they were trying to save. The psychological mechanism underlying this phenomenon operates through what we might call self-fulfilling prophecy amplified by temporal anxiety, where the mind creates such a vivid internal model of an unwanted future that it unconsciously engineers present behaviors aligned with reaching that future state, treating the feared outcome as inevitable, and thereby robbing itself of the flexibility and optimism necessary to chart a different course. We have normalized this pattern so thoroughly in our culture that we barely recognize it as paradoxical at all, accepting it as simple cause and effect, a natural consequence of bad luck or poor decision-making, when in fact the paradox reveals something far deeper about the relationship between our predictions, our fears, and the reality we collectively construct through the choices we make, while believing those choices are merely reactions to predetermined circumstances rather than the very forces that predetermine those circumstances. The paradox invites us to question whether breaking free from a feared outcome requires not the desperate effort to prevent it, but rather a fundamental shift in our relationship to uncertainty itself, a willingness to hold our predictions lightly enough that we might perceive and choose differently in each moment, recognizing that the future remains genuinely open so long as we refuse to treat our anxieties as oracles. This paradox ultimately suggests that our greatest power lies not in controlling outcomes, but in transforming our relationship to fear itself, learning to distinguish between genuine intuition and anxiety masquerading as foresight, so that we might respond to life's uncertainties with curiosity rather than defensiveness. openness rather than protective closure. When we examine our lives in retrospect, we often discover that the pivotal moments we dreaded most were frequently the very circumstances that catalyzed our greatest growth, suggesting that the predestination paradox may ultimately be resolved not by preventing feared futures, but by developing the wisdom to recognize that resistance itself is what solidifies these outcomes into our reality. Imagine a photon traveling through space toward a detector, and imagine that somewhere along its journey, you have the ability to make a choice that will fundamentally alter what that photon has already done in the past. This is the essence of the delayed choice experiment, a thought experiment first proposed by physicist John Wheeler in 1983, which suggests that the act of measurement in quantum mechanics is not constrained by the arrow of time as we understand it. In the traditional double-slit experiment, we know that a particle behaves like a wave when unobserved and like a particle when observed. But in the delayed choice version, the observation happens after the particle has already passed through the apparatus, yet somehow retroactively determines its behavior. The experiment begins with a photon emitted from a source, traveling toward two possible paths it could take, and this photon exists in a superposition of states, moving through both paths simultaneously as a wave would. However, before the photon reaches its final destination, you insert a detector or remove it, making a choice about whether you will measure which path the photon actually took, and this choice is made after the photon has theoretically already committed to its journey. What emerges from this conceptual framework is deeply unsettling. The universe appears to respond to your future measurement by adjusting what the photon did in the past, creating a loop of causality that flows backward through time. The psychological mechanism at work here involves our fundamental inability to accept that observation itself shapes reality, that the past is not fixed and immutable, but rather remains in a state of potentiality until consciousness collapses it into fact. We have built our entire intuitive understanding of time on the assumption that the past is written, that what has happened is done and cannot be undone or rewritten, yet quantum mechanics whispers something far stranger to us. That reality is fundamentally participatory, that the universe requires an observer not just to know about events, but to actualize them. We have normalized this paradox by accepting it within the narrow domain of quantum mechanics, while maintaining our classical intuitions about the everyday world, creating a comfortable cognitive separation between the realm of the infinitesimally small and our macroscopic experience. Yet this division may itself be an illusion we have constructed to avoid confronting the deeper truth that time, causality, and observation are far more interwoven than we have ever dared to imagine. Perhaps the most humbling aspect of the delayed choice experiment is that it forces us to abandon the comfortable illusion of a universe that exists independently of our engagement with it, suggesting instead that reality itself is an ongoing negotiation between observer and observed, where the future reaches backward to reshape what we thought was already settled. In this view, the scientist conducting the experiment is not merely a passive recorder of nature's secrets, but an active participant in authoring reality itself. And perhaps this is why the delayed choice experiment remains so philosophically troubling. It suggests that we cannot study the universe from some neutral vantage point outside of it, but must acknowledge our inescapable entanglement with the very phenomena we seek to understand. Imagine a laboratory where physicists send individual photons, particles of light, through two slits in a barrier, and on the other side they place a screen to detect where these photons land. And what they discover is that when no one is watching which slit the photon goes through, it behaves like a wave and creates an interference pattern with itself, spreading across the screen in bands of light and dark. But the moment the scientists set up a detector to observe which slit the photon actually uses, the photon behaves like a particle and goes through one slit or the other, creating two distinct bands on the screen instead of an interference pattern, as if the universe itself changes its behavior based on whether or not it is being observed. Now comes the stranger part. In the quantum eraser experiment, physicists add another layer of complexity by setting up their detectors in such a way that they can determine which slit the photon went through. But then, crucially, they erase that information before it ever reaches a conscious observer. They scramble it, they render it unknowable, and when this happens, the interference pattern mysteriously returns, as if the photon retroactively decides to have gone through both slits all along, undoing its previous decision to be a particle. The mechanism underlying this bewildering behavior seems to hinge on the nature of information itself and possibility itself, suggesting that reality at the quantum level does not commit to a definite state until information about that state becomes knowable in principle. that the act of erasing information about which path was taken somehow rewrites history backwards in time, collapsing the wave function not forward into the future, but backward into the past. Creating a causal loop where the future erasing of information influences the past behavior of the photon. What makes this profoundly unsettling is that it suggests the present moment has no fixed reality independent of what will be known about it later, that the past is not settled until the future decides what information about it will be preserved, and yet despite this fundamental weirdness, this experiment has been replicated countless times, confirmed by physicists across the world, and incorporated into standard quantum mechanics textbooks as simply how reality operates at its most basic level, treated almost as mundane, as if the discovery that information causality and temporal direction might be illusions rather than features of a real objective past, has not fundamentally shattered our understanding of existence itself. And yet when physicists casually discuss these results over coffee, they speak of it with the same detachment one might use to describe the weather, as though they have not just demonstrated that the universe operates according to principles that seem to require consciousness, information, and causality to be radically different from what our intuitions insist they must be, that somewhere in the mathematics of quantum mechanics lies a truth so strange that we have simply decided to stop being surprised by it. In 1949, the mathematician Kurt Gödel made a discovery within Einstein's equations of general relativity that suggested something profoundly unsettling about the nature of time itself. Gödel found that if the universe were rotating as a whole, if everything around us was spinning in an enormous cosmic dance, then it would be mathematically possible to travel backward through time by following a specific path through spacetime. This wasn't a fantasy or a metaphor. It was a legitimate solution to the equations that govern how gravity shapes reality. The model required the universe to possess a particular density and rotation rate, conditions that seemed impossible, yet the mathematics held firm. What made this discovery so philosophically troubling was not merely that time travel appeared possible, but that it revealed something deeper about time itself. Time as we experience it, as a river flowing only forward, might not be a fundamental feature of reality at all. Instead, our sense of temporal direction might emerge from the universe's current state of expansion and the thermodynamic arrow of entropy, not from anything intrinsic to time's nature. If you could construct a rotating universe, the arrow of time would vanish entirely, and causality would transform into something alien to our intuition. The mechanism underlying this paradox stems from spacetime's geometric nature, the way that massive spinning objects can curve the very fabric of existence around them. In Gödel's model, closed time-like curves, paths through spacetime that loop back on themselves, become unavoidable. An observer traveling along such a path would arrive at their own past, meeting themselves at an earlier moment of their own existence. The universe itself becomes a labyrinth where cause and effect tangle into impossible knots. Our minds struggle with this because we evolved in a universe with a clear temporal direction, where memories point backward and possibilities point forward. Our brains are wired to understand time as asymmetrical and irreversible. The notion that this asymmetry might be merely an artifact of local conditions rather than a fundamental law contradicts every instinct we possess about reality's structure. Yet despite the decades that have passed since Gödel published his work, despite the fact that observations suggest our universe is expanding rather than rotating, the paradox persists in our collective consciousness. We have normalized the notion that our experience of time might be fundamentally misleading, that the universe's apparent arrow of time might be nothing more than a temporary local condition imposed by entropy and expansion. We accept that beneath the surface of our everyday experience, time itself might be symmetric, timeless, and entirely indifferent to our sense of past and future, and we continue moving through our days as though this knowledge changes nothing at all. Yet in this very disconnect lies perhaps the deepest insight, that our inability to live as though time is symmetric, our stubborn insistence on experiencing causality and consequence, may be the universe's way of protecting us from the vertigo of its own true nature. We are creatures built to survive in time's river, not to navigate the still waters beneath. Imagine a path through spacetime so perfectly curved that it loops back on itself, creating a trajectory where a traveler could theoretically depart from a moment in time and arrive at an earlier point in their own past, having experienced the journey as a continuous forward progression despite moving backward through the calendar. And this is precisely what physicists call a closed time-like curve, a concept that emerges not from science fiction, but directly from the equations of general relativity. Einstein's theory that describes gravity as the curvature of spacetime itself. These curves are not merely theoretical abstractions confined to blackboards and academic journals, because the mathematical framework that governs our universe, the very equations we use to predict planetary orbits and explain the behavior of black holes, does not explicitly forbid their existence, and in fact, several mathematically valid solutions to Einstein's field equations contain these loops in causality, including the Kerr metric describing rotating black holes and the Tipler cylinder, a theoretical infinite cylinder spinning at relativistic speeds. The psychological mechanism that makes closed time-like curves so profoundly disorienting is that they violate our deepest intuition about cause and effect, the fundamental assumption that causes must precede their effects in time, that you cannot pull a trigger and then have the bullet exist before the gun was fired. Yet the universe's governing equations remain silent on this principle, treating temporal direction as merely another dimension in the fabric of spacetime. No more sacred or privileged than the three dimensions of space we navigate every day. What persists despite the logical paradoxes is our continued belief that time must flow in only one direction, that causality is inviolable, and that the arrow of time is fundamental rather than emergent. Yet we have normalized the existence of closed time-like curves in our physics textbooks and our understanding of black hole thermodynamics. Accepting their mathematical validity while simultaneously hoping they remain forever inaccessible behind event horizons, where their paradoxes cannot threaten the coherence of our lived experience. Trapped in a curious state where we acknowledge the universe permits something we simultaneously insist cannot actually happen. Perhaps this is why the Novikov Self-Consistency principle has gained traction among physicists. The idea that any action taken by a time traveler must be consistent with history as we already know it, a mathematical framework that permits closed time-like curves while preserving causality through an almost fatalistic constraint, suggesting that the universe itself might enforce consistency through mechanisms we do not yet comprehend. Transforming paradox into merely an illusion born of our incomplete understanding. In this view, the universe becomes not a stage where time travel creates branching paradoxes, but rather a self-editing narrative where the past is as fixed and immutable as the present moment, and any attempt to change history simply becomes part of the history that always was, rendering the time traveler not a rebel against causality, but an unwitting author writing the very script they believed they were rewriting. Imagine the universe in its final moments, billions upon billions of years from now, when all stars have burned out, all black holes have evaporated, and only the faintest quantum fluctuations ripple through an otherwise empty void of infinite darkness and cold. In this incomprehensibly distant future, according to certain interpretations of thermodynamics and statistical mechanics, something strange and deeply unsettling becomes inevitable. A conscious brain will spontaneously assemble itself from random atomic particles, existing for merely a fraction of a second before dissolving back into chaos. This is the Boltzmann brain, a thought experiment named after 19th-century physicist Ludwig Boltzmann, and it presents a paradox so profound that it challenges the very foundation of how we understand consciousness, probability, and the nature of existence itself. The mechanism underlying this paradox rests on a simple but devastating mathematical principle. Given infinite time and an infinite universe, every possible configuration of matter will eventually occur, including arrangements that would constitute a functioning human brain complete with memories, thoughts, and subjective experience. This consciousness would not have evolved through any biological process or accumulated genuine experiences, yet from its own internal perspective, it would possess all the hallmarks of a genuine mind. The troubling extension of this logic is that, statistically speaking, such random Boltzmann brains would vastly outnumber all brains that have ever evolved naturally through biological processes across the entire history of the cosmos. By the cold calculations of probability alone, the overwhelming majority of all conscious observers that will ever exist should be these ephemeral, meaningless fluctuations, rather than beings with authentic histories and genuine memories. Yet despite the logical rigor of this argument and its unsettling implications for our own ontological status, we persist in our assumption that our consciousness is real, our memories are genuine, and our existence is not merely the fleeting delusion of a quantum fluctuation. We continue to build meaning and purpose into our lives as though this paradox does not exist, carrying forward with our daily concerns and long-term projects with an almost willful blindness to the possibility that we ourselves might be nothing more than the universe briefly dreaming a false dream, conscious ghosts arising from statistical improbability before vanishing forever into the void. Perhaps this is not blindness at all, but rather an act of epistemic humility, an acknowledgement that some questions exceed the reach of our reasoning, and that the only rational response to infinite uncertainty is to live as if our experiences matter, to treat our memories as real, and to accept that meaning is something we must create rather than discover. In this light, the Boltzmann Brain Paradox becomes less a refutation of our existence and more a mirror reflecting back our deepest uncertainty, a reminder that consciousness itself remains one of the universe's most formidable mysteries, resistant to reduction and perhaps forever beyond complete rational resolution. And yet, in choosing to live meaningfully despite this uncertainty, we perform an act of quiet rebellion against a universe indifferent to our existence. We assert that consciousness, however it arose, deserves to be lived fully and without apology. Imagine a closed room filled with gas molecules bouncing randomly against the walls, and imagine waiting long enough, so impossibly long that the number of years would make the age of the universe seem like a brief moment. And according to the mathematical principle known as Poincaré Recurrence, those molecules would eventually return to their exact starting configuration through pure chance and the relentless mechanics of probability, meaning that every atom would be in precisely the position it was before, recreating the moment perfectly as if time had somehow cycled backward or folded upon itself. This principle emerged from Henri Poincaré's work in celestial mechanics in the 1890s, when he proved that in a closed system with finite energy, any arrangement of particles must eventually recur if given sufficient time, because there are only finitely many possible states those particles can occupy, and therefore by the pigeonhole principle alone, the system must repeat itself eventually, cycling through configurations in a way that seems to suggest that time itself might be less like a river flowing forward, and more like an enormous, incomprehensibly slow spiral that returns eternally to places it has been before. The psychological weight of this idea rests in the contradiction it reveals between what thermodynamics tells us about entropy and time's arrow. Because we experience time as irreversible and directional, yet Poincaré's mathematics insists that on timescales so vast our minds cannot conceptualize them, reversibility is not just possible, but inevitable, suggesting that our perception of time flowing only forward might be an artifact of our existence in an impossibly brief window within an eternal cycle. We have normalized this paradox by simply accepting the practical irrelevance of recurrence, acknowledging that the timescales involved are so astronomically large that they function as mathematical curiosities rather than physical realities we need to consider. Yet the deeper implication persists uneasily in the background of modern physics, that perhaps the universe is fundamentally neither created nor destroyed, but eternally recurring, and that the sense of progress and change and history we experience is merely the local perspective of beings who live and die long before any recurrence could manifest, making our entire narrative of time perhaps nothing more than a brief chapter in an infinitely long book that repeats itself endlessly across eternities we will never witness. Yet there is a strange comfort in this vision, for if the universe truly cycles through all possible states infinitely, then in some distant recurrence, this moment, this reading, this thought, this very consciousness will occur again, suggesting that nothing is ever truly lost, only temporarily separated from itself by the vast gulfs of time that stretch between one cycle and the next. And yet this comfort dissolves upon closer examination, for even if recurrence is mathematically guaranteed, the recurrence would be indistinguishable from non-recurrence to any observer within it, since memory itself would reset with each cycle, leaving us eternally unaware that we have lived this exact life before, and will live it again, forever trapped in what feels like the first time. Imagine standing at the edge of a vast canyon, looking out across the same landscape you have seen countless times before, and yet each time you arrive at this vantage point, it feels as though you are experiencing it for the first time, as if the universe has reset itself and begun again from the exact same starting conditions, with you positioned identically to how you stood yesterday, last week, and last year. This is the essence of eternal return, a concept that suggests if the universe is infinite in both time and space, then eventually all possible configurations of matter and energy must repeat themselves infinitely, meaning that your current moment, your precise thoughts, your exact position in space relative to every star and atom, has occurred before and will occur again, an infinite number of times across an incomprehensibly vast eternity. The psychological mechanism at work here involves our perception of linear progression and the comfort we derive from believing that time moves forward irreversibly, carrying us along a unique path that will never be retraced. We experience our lives as singular narratives, each moment distinct and unrepeatable, each choice creating new branches of possibility that diverge forever into the future. Yet if we accept the mathematics of infinity and the finite nature of possible atomic arrangements, the logical conclusion becomes inescapable. Everything that has happened must happen again, and again, and again, eternally, without variation or escape. We have normalized this profound paradox by rarely confronting it directly, by compartmentalizing our understanding of physics and philosophy, by choosing to believe in the special significance of our individual existence, even while scientific principles suggest our lives are merely echoes in an eternal cosmic recurrence. The idea remains lurking at the margins of our consciousness, neither fully accepted nor fully rejected, creating a strange cognitive dissonance that we manage by simply not thinking about it, allowing ourselves to move through our days with the comfortable illusion of genuine novelty and progress. Yet there is a peculiar liberation in this thought if we allow ourselves to truly sit with it. If everything recurs infinitely, then your suffering will recur infinitely, but so too will every moment of beauty, every laugh, every unexpected kindness, preserved forever in the cosmic repetition, eternally real across the vast expanse of time. And perhaps this is why the ancient philosophers who contemplated eternal return found in it not despair but a strange affirmation. The mandate to live in such a way that you would be content to live your exact life, again and again, forever, transforming each moment from mere occurrence into deliberate choice. This reframing shifts eternal return from a source of paralysis into a call for intentionality. Every meal becomes sacred because you will taste it infinite times. Every conversation gains weight because these exact words will echo through eternity, and even the smallest act of compassion ripples infinitely across the abyss of recurrence, making the ordinary extraordinary through the lens of cosmic repetition. Imagine watching a film of a coffee cup falling from a table and shattering into pieces on the ground, and then imagine watching that same film played in reverse, showing the scattered fragments reassembling themselves back into a whole cup that rises upward through the air to land softly on the table. The first scenario feels natural, inevitable, and correct, while the second feels absurd, impossible, and deeply wrong, yet at the level of fundamental physics, both sequences violate no laws whatsoever. This intuitive sense that time flows in only one direction, that the past is fixed while the future remains open, that disorder inevitably increases and order naturally decays, is what physicists call the arrow of time, and it represents one of the most profound paradoxes in our understanding of reality. The mechanism behind this arrow emerges not from any fundamental law of physics, but rather from statistics and probability, from the sheer mathematical fact that there are vastly more ways for a system to be disordered than ordered, and therefore it is extraordinarily unlikely that a broken cup will spontaneously reassemble itself, even though the underlying physics permits it. We experience this arrow of time as something absolute and unidirectional because we exist in systems of tremendous complexity containing uncountable particles, where the probability of returning to a previous state is so vanishingly small that it might as well be impossible, and yet here is the paradox that haunts this explanation. The laws of physics themselves, when written in their most fundamental form, are entirely time-symmetric, meaning they work exactly the same whether time moves forward or backward, suggesting that our experience of time's flow is merely an artifact of our perspective rather than a feature of reality itself. We have normalized this paradox so completely that we rarely question it, accepting without hesitation that eggs cannot unbreak, that hot tea cannot spontaneously become hotter while the room grows colder, that memory flows only backward while anticipation reaches only forward. And yet if we examine the physics underlying these everyday observations, we find only equations that function perfectly well in either temporal direction, revealing that the arrow of time might be less a fundamental property of the universe and more a consequence of initial conditions and statistical likelihood, a collective illusion constructed from our position as conscious beings embedded within vastly complex systems where order is so rare and precious that its persistence strikes us as the natural state of things. Yet this realization transforms how we understand our own existence. Consciousness itself may be fundamentally tied to this arrow, our ability to remember the past and anticipate the future emerging not from any special property of mind, but from our embeddedness within systems of such overwhelming complexity that the statistical gradient between past and future becomes the very substrate upon which thought and identity are built. If we accept this possibility, we must confront a vertiginous question. Would consciousness be possible in a universe without an arrow of time, in a cosmos where past and future held equal ontological weight, or is the directional flow of time not merely compatible with mind, but absolutely necessary for its existence? Consider a simple scenario that seems almost mundane in its ordinariness. You pour cream into a cup of hot coffee and watch as the cream disperses throughout the liquid, creating swirling patterns that eventually dissolve into an even, uniform brown mixture that can never be unmixed. This everyday observation sits at the heart of one of physics' most profound paradoxes, first articulated by the Austrian physicist Joseph Loschmidt in the 19th century. The paradox emerges from a troubling logical contradiction between the fundamental laws of motion, which operate identically whether time moves forward or backward, and the apparent one-directedness of entropy, which always seems to increase, never to decrease, in the direction we experience as the future. If the microscopic equations that govern the behavior of individual atoms and molecules are completely reversible, meaning that if you theoretically reverse the direction of every particle's motion at any given moment, the system should naturally retrace its steps and return to its original state, then how can it be that the macroscopic world so clearly marches in one direction only? Never spontaneously unmixing the cream from the coffee or reassembling a broken glass from its scattered fragments. The psychological mechanism that allows us to overlook this paradox lies in our intuitive acceptance of probability and statistical likelihood. We understand, on some deep level, that while the laws of physics technically permit the cream to separate from the coffee, if every molecule suddenly reversed its direction simultaneously, the probability of this occurring by chance alone is so astronomically small that it effectively never happens, so small in fact that the number of atoms in the observable universe seems trivial by comparison. Yet this explanation, while mathematically satisfying, merely pushes the question deeper rather than truly resolving it, because it requires us to accept that the laws governing microscopic particles are genuinely indifferent to temporal direction, and that the arrow of time we experience so intensely in our everyday lives emerges only from statistical improbability rather than from any fundamental asymmetry in the laws themselves. We have normalized this paradox by accepting it as simply the nature of how thermodynamics works, treating entropy as a practical tool rather than confronting the unsettling implication that time's direction might be nothing more than an elaborate statistical illusion. Yet perhaps this is precisely where the paradox gains its philosophical power, in forcing us to recognize that the distinction between a law of physics and a statistical tendency may itself be a human construct, a convenient boundary we draw between what we understand as fundamental and what we dismiss as merely probable, when in reality both emerge from the same underlying indifference of nature to our preference for ordered beginnings and disordered endings. This recognition invites us to reconsider whether the universe truly prefers disorder, or whether we simply find ourselves observers embedded within an extraordinarily improbable configuration of matter, one that, from the perspective of eternity, might be as statistically anomalous as a shuffled deck spontaneously arranging itself into perfect order, yet no less real for its unlikelihood. Imagine a sealed container divided into two chambers by a wall with a tiny door, and imagine that this door is operated by an impossibly small being, a molecular-scale creature with perfect vision and reflexes, capable of watching individual gas molecules as they approach the barrier separating hot molecules from cold ones, opening the door only when a fast-moving hot molecule approaches from the left chamber, then closing it quickly. Or alternatively opening it only when a slow cold molecule drifts toward it from the right, allowing these temperature-sorted molecules to migrate across the boundary until eventually one side becomes scorching hot and the other becomes frigid cold, all without any external work being performed, no energy input beyond the demon's observation, which seems to violate the second law of thermodynamics, the fundamental law of physics that insists entropy always increases. That disorder always spreads, that you cannot spontaneously separate hot from cold without expending energy, yet here theoretically is a mechanism that appears to do exactly that. The profound paradox Maxwell articulated in the 1800s sits at the intersection of information, entropy, and the nature of measurement itself. For what the demon does through its molecular sorting is equivalent to extracting useful work from pure information, from mere knowledge of which molecules are moving quickly versus slowly, and the question becomes whether information itself costs energy to gather and process. Whether the act of observation inherently generates entropy elsewhere in the system, whether the demon's brain or sensory apparatus must dissipate heat and disorder precisely equal to the order it creates by sorting molecules. Physics has since determined that yes, the measurement must cost energy, that information and entropy are fundamentally linked, that you cannot observe a molecule without disturbing the universe in some way. Yet the demon persists in our imagination as a thought experiment that reveals something deeply strange about reality, about how knowledge and order are not free gifts but purchases paid in entropy. And we continue to invoke Maxwell's creature when discussing artificial intelligence and automated systems and surveillance technologies, wondering whether the gathering of perfect information about complex systems might itself carry hidden thermodynamic costs, whether the universe imposes a fundamental tax on observation itself, suggesting that true omniscience remains impossible not for practical reasons, but for physical ones, built into the very structure of existence. Perhaps this explains why even our most powerful computers, no matter how sophisticated their algorithms or sensors, can never quite achieve the frictionless omniscience we imagine, why the dream of perfect prediction or total surveillance always dissolves into noise and uncertainty, why the universe itself seems designed to keep secrets hidden behind the thermodynamic cost of knowing them. And so the demon becomes a mirror held up to our own ambitions, a reminder that every camera watching a street, every algorithm parsing human behavior, every attempt to extract order from chaos leaves behind a wake of entropy, a debt paid not in currency, but in the fundamental disorder of the universe itself. Imagine a judge who announces to a prisoner that an execution will take place at noon on one day during the following week, but the prisoner will not know which day until the morning of the execution itself, at which point the hanging will come as a complete surprise. The prisoner, reasoning logically through this paradox, begins to work backwards through the days of the week, eliminating each one systematically. He thinks to himself that if the hanging has not occurred by Friday morning, then he would know with absolute certainty that it must happen on Friday, which would mean it would not be unexpected, violating the judge's stated condition. Therefore, Friday is eliminated. But then, applying the same logic to Thursday, if the hanging has not occurred by Thursday morning, he would know it must be Thursday, since Friday is impossible, which means Thursday is also eliminated. This reasoning continues relentlessly through Wednesday, Tuesday, and Monday, until the prisoner concludes that no day can satisfy the judge's conditions, and therefore the execution cannot happen as promised. Yet when Wednesday arrives, the guards come to collect him, and despite his supposedly airtight logical reasoning, the execution is indeed unexpected, and the prisoner is taken completely by surprise. The paradox persists because we tend to treat two different notions of expectation as if they were the same thing, conflating subjective knowledge with logical deduction. The prisoner's reasoning is sound within its own framework, yet it fails to account for the fact that knowledge of an event can be withheld from someone even when they possess the logical tools to deduce when that event should occur. The paradox reveals something strange about how our minds process certainty and how our confidence in logical reasoning can become disconnected from the reality of lived experience, creating a gap between what we think we can predict and what actually happens to us in time. This disconnect between logical certainty and experiential surprise mirrors many paradoxes in mathematics and philosophy, from Zeno's dichotomy to the Sorites paradox, each revealing how our systems of reasoning can produce conclusions that seem ironclad yet fail to capture the full texture of how time, knowledge, and reality actually unfold. In this sense, the unexpected hanging reminds us that certainty itself is a slippery thing. What we can prove logically, and what we can know experientially remain stubbornly separated by the lived moment, the instant where thought transforms into reality, and where the prisoner's confidence in his reasoning shatters against the simple fact of the guards at his cell door. Perhaps this is why the paradox has haunted logicians and philosophers for decades. It does not merely puzzle the mind with an abstract contradiction, but forces us to confront the uncomfortable truth that our rational faculties, for all their power, cannot eliminate the fundamental uncertainty that accompanies us through time, and that sometimes the most rigorous thinking can only prepare us for surprise, never prevent it. The prisoner's error, in retrospect, reveals that the act of reasoning about uncertainty can itself alter the conditions of that uncertainty. The moment he tries to escape the paradox through logic, he has already changed the very framework in which the paradox operates, much like how observing a quantum particle changes its behavior. Imagine a superintelligent being, so advanced in its predictive abilities that it can foresee your choices with near-perfect accuracy, presents you with two boxes, and explains the rules of an extraordinary game. The first box is transparent and contains $1,000 that you can plainly see, while the second box is opaque and sealed before you, containing either $1 million or nothing at all, depending entirely on what this being predicted you would do before the game even began. You are given a choice. You may take both boxes, or you may take only the opaque box, and whatever decision you make right now will determine what was placed inside that sealed container in the past, according to the being's prediction of your present choice. The paradox emerges from a fundamental collision between two equally rational frameworks for decision-making, because if you believe the being's prediction is truly reliable, you should take only the opaque box and trust that it predicted your restraint and filled it with $1 million. Yet if you employ standard decision theory, you should take both boxes since the contents are already determined, and an additional $1,000 can only improve your outcome. This problem haunts our intuitions because it forces us to confront the relationship between prediction and causation, between free will and determinism, between what we think we should do and what our logic tells us we will do. The psychological mechanism underlying our struggle with this dilemma stems from our deep uncertainty about whether our decisions are truly free choices or inevitable outcomes that a sufficiently advanced observer could have seen coming. And this uncertainty makes every option feel simultaneously correct and catastrophically wrong depending on which assumptions we privilege. We have normalized living with this tension in our everyday lives without ever truly resolving it, accepting that we make choices while simultaneously believing those choices might have been predictable, inevitable, or even illusory all along, creating a perpetual unease that we generally choose not to examine too closely as we drift further into contemplation. Yet perhaps this avoidance itself reveals something essential. Our reluctance to fully examine Newcomb's problem may stem not from intellectual inadequacy, but from a deeper recognition that resolving it would require us to fundamentally redefine agency itself, to accept either that our choices are illusory shadows cast by predictable patterns, or that genuine freedom exists in a universe where nothing, not even our most intimate decisions, remains truly opaque to sufficiently powerful observation. And in this way, Newcomb's problem becomes less a puzzle to be solved and more a mirror reflecting back our deepest anxieties about control, knowledge, and the nature of choice itself. A mirror we can study only by accepting that the act of looking changes nothing about what we already are. Perhaps this is why we return to Newcomb's problem again and again across centuries and disciplines, not seeking escape from the paradox, but drawn inexorably toward the abyss it opens, each confrontation another opportunity to glimpse the invisible architecture underlying our sense of self and consequence. Imagine a woman named Sleeping Beauty who agrees to participate in a strange experiment that challenges the very foundations of probability and self-knowledge. And in this experiment, she is put to sleep on a Sunday evening, and then a fair coin is flipped to determine what happens next. And if the coin lands on heads, she will be awakened on Monday, have a brief conversation with the experimenters, and then be put back to sleep with a memory-erasing drug administered so she will have no recollection of this Monday awakening. And if the coin lands on tails, she will be awakened on both Monday and Tuesday, again with the memory-erasing drug given after each awakening so that she remains unaware of how many times she has been roused. And then she will be awakened one final time on Wednesday and the experiment ends, and the crucial question becomes this. When Sleeping Beauty wakes up during the experiment, having no memory of any previous awakenings, what should she believe is the probability that the coin landed on heads rather than tails? The logical puzzle emerges from the collision between two different ways of counting outcomes, because from an outside perspective, before the experiment begins, the coin has a 50% chance of landing on heads and a 50% chance of landing on tails, yet from Sleeping Beauty's perspective, trapped in a single awakening moment with no context, she experiences heads once and tails twice, which would suggest a 2/3 probability that she is experiencing a tails awakening rather than heads, and this paradox persists because it forces us to confront the relationship between objective probability and subjective experience, between the perspective of an observer outside the system and the perspective of someone embedded within it, unable to distinguish between identical moments that might have occurred under different conditions. And the problem gains its unsettling quality because even after extensive logical analysis and debate among philosophers and probability theorists, there remains no universal consensus about which answer is correct, suggesting that our intuitions about probability and identity in consciousness are fundamentally unstable when pushed to their limits. And this uncertainty about so simple a question illustrates how our confident grasp of logical certainty dissolves when we examine the relationship between time and knowledge and the nature of what it means to be aware during any given moment. Some philosophers argue that Sleeping Beauty should answer one half, reasoning that her personal subjective experience shouldn't alter the objective 50-50 outcome of the coin flip itself, while others defend the two-thirds answer by pointing out that from her isolated perspective within the experiment, the statistical likelihood of any random awakening belonging to a tails scenario is genuinely twice as probable. And this disagreement reveals how the same logical facts can support radically different conclusions, depending on whether one privileges the external, timeless view of probability or the internal, embedded perspective of the experiencing subject. Imagine standing in a vast auditorium where humanity sits, and you're told that you must guess your position in the row. You have no special information about yourself, no reason to believe you're exceptional or particularly early or late in the sequence. Yet the moment you accept that you are indeed sitting somewhere in this row, a strange logical trap emerges, one that suggests humanity itself might be approaching its final act far sooner than our optimistic timelines would predict. This is the essence of the Doomsday Argument, a philosophical paradox that emerges from the application of basic probability theory to human existence itself, and it whispers an unsettling conclusion that we are likely living much closer to the end of human history than we might hope. The argument proceeds with deceptive simplicity. If we assume that your birth rank among all humans who will ever exist is random and uniformly distributed, then statistically speaking, you are probably somewhere in the middle of that distribution, not at the extreme beginning or end. Since approximately 100 billion humans have already been born, and you exist now, it becomes mathematically probable that only a similar number or fewer humans will be born after you before humanity's extinction or radical transformation occurs. This means humanity might have only centuries or a few millennia remaining, rather than the millions of years that space exploration enthusiasts envision. The mechanism that makes this argument so psychologically troubling is precisely what makes it so intellectually interesting. It takes our intuitive understanding of probability and applies it to a domain where we have no obvious reason to believe probability should apply at all. We do not normally think of our existence as a random draw from the set of all possible humans throughout history, yet the argument insists that if we reject that premise, we must also reject the foundation of our statistical reasoning itself. The paradox persists in philosophical literature despite widespread skepticism because no consensus has emerged on exactly where the argument fails, if indeed it fails at all. Some philosophers argue that the self-selection problem renders the argument invalid, that by conditioning on our own existence, we have already biased the sample in ways that make the probability calculation meaningless. Others suggest that the very concept of a fixed human population size becomes incoherent once you consider quantum mechanics or the possibility of infinite futures. And still others propose that our ignorance about future technological advancement makes any such calculation epistemically unjustifiable. Yet the argument endures, not because it has been proven true, but because its logical structure remains difficult to definitively disprove, creating a persistent intellectual unease about the trajectory of human civilization, and reminding us that even our most basic assumptions about probability might conceal hidden vulnerabilities when applied to the question of existence itself. Imagine a lamp that switches on and off with perfect precision, controlled by an infinite sequence of actions compressed into a finite amount of time, and consider what happens when you ask the simplest possible question about its final state. James F. Thomson, a philosopher working in the mid-20th century, conceived of this thought experiment to challenge our understanding of infinity, completion, and the very possibility of bringing an infinite series of events to a meaningful conclusion. The lamp begins switched off, and then at half a minute before noon, it switches on, and then at a quarter minute before noon, it switches off, and then at an eighth of a minute before noon, it switches back on again, and this pattern continues indefinitely, with each switch occurring at half the remaining time interval, so that infinitely many switches happen before noon actually arrives. The intervals shrink exponentially, never quite reaching zero but approaching it asymptotically, which means that, mathematically speaking, all infinite switches are completed by the moment noon arrives. Yet when you ask whether the lamp is on or off at exactly noon, having completed this infinite sequence of alternating states, there is no logical answer, because there is no final switch to determine the lamp's ultimate state. The paradox emerges not from the mathematics, which is perfectly consistent and well understood, but from our intuition that any infinite process must have some definable conclusion, some final configuration that represents its completion. We assume that if something can be mathematically completed, it must have a determinate outcome, yet Thomson's lamp reveals a gap between mathematical convergence and physical or logical determinacy. Our minds struggle with this because in every experience we have, processes do eventually end, switches do eventually land in a final position, and infinity remains something we encounter only in abstraction rather than in actual completed events. We have grown accustomed to treating infinity as purely a mathematical convenience, something that helps us calculate and predict, yet we rarely confront scenarios where infinity might actually be realized in a concrete situation, which is perhaps why this paradox continues to perplex philosophers despite being perfectly described within standard mathematics, suggesting that our comfort with the infinite might be more fragile than we realize. Some have argued that Thomson's lamp reveals not a flaw in mathematics, but rather a warning about the limits of applying mathematical idealization to the physical world, where infinite divisibility of time may not correspond to any reality we can actually observe or measure. Others contend that the paradox dissolves entirely if we simply accept that certain questions, like the lamp's state at noon, are genuinely meaningless rather than unanswerable, pointing toward a more humble conception of what infinity can and cannot tell us about existence itself. Perhaps the deepest lesson of Thomson's lamp is that it forces us to distinguish between what mathematics can describe and what the universe can actually instantiate, a distinction that becomes ever more crucial as we contemplate the nature of time, causality, and whether infinity is merely a tool of human thought or a genuine feature of reality itself. Imagine you have an infinite collection of numbered balls, and you begin a peculiar procedure that unfolds across time. You take balls numbered 1 through 10 and place them into an empty urn, then you remove the ball numbered 1, leaving 9 balls inside. Next, you add balls numbered 11 through 20 into the urn, then remove the ball numbered 2, leaving 18 balls. You continue this process indefinitely, always adding 10 new balls and removing one existing ball, which means with each iteration the total number of balls in the urn increases by 9. After infinite iterations, you would expect the urn to contain infinitely many balls, yet when you examine which specific balls remain inside, you discover something profoundly disturbing. Every single numbered ball that you ever placed into the urn has been removed. The urn is completely empty. This is the Ross-Littlewood Paradox, named after the mathematicians who formalized it, and it reveals a fundamental tension between our intuitions about infinity and the cold logic of mathematical operations performed across endless time. The mechanism operating here involves the distinction between finite and infinite quantities in ways that seem to violate our everyday understanding of addition and subtraction. When you add 9 balls net each step, your intuition screams that infinity plus anything should remain infinite, yet the removal pattern ensures that eventually every single ball gets taken out, because every ball has a removal step waiting for it in the infinite future. The paradox persists because our minds evolved to handle finite quantities where such contradictions cannot emerge, yet we have built mathematical systems robust enough to describe infinity, and those systems reveal that our intuitions about accumulation become unreliable at these scales. We have grown accustomed to these strange truths not because they make sense, but because we have learned to trust the formal logic behind them more than our own sense of what seems reasonable. In this way, the Ross-Littlewood Paradox joins a family of infinite paradoxes, like Galileo's infinite sets or Zeno's dichotomy, that collectively demonstrate how infinity is not merely a larger version of finite quantity, but operates according to fundamentally different rules that require us to abandon our intuitive frameworks entirely. The paradox also demonstrates that infinity is not a quantity but a process, and the order in which operations unfold matters profoundly, a lesson that extends far beyond mathematics into physics, where time's arrow and causality shape which infinities we encounter. In this sense, the empty urn at the end is not a logical contradiction, but rather a humbling reminder that our ability to describe infinity formally does not grant us intuition about it, only the hard-won discipline to accept conclusions that violate every instinct we possess. Yet this acceptance itself becomes the gateway to deeper understanding. Once we release our grip on intuitive expectation and allow the mathematics to guide us, we begin to see that infinity operates not as a mysterious realm beyond comprehension, but as a domain governed by precise rules about order, timing, and asymptotic behavior. Rules that, while foreign to our everyday experience, possess their own elegant logic and internal consistency. Imagine a library where a librarian is tasked with completing an infinite number of books in a finite amount of time, and consider that this is not merely a thought experiment, but a representation of something our minds encounter in mathematics and logic on a regular basis. The supertask, as philosophers and logicians call it, describes any process where an infinite number of actions are completed in a finite duration, and the most famous example remains Zeno's dichotomy paradox reformulated through Thomson's lamp, where a switch is flipped infinitely many times between on and off, with each flip taking half the time of the previous flip, meaning that after 1 second, an infinite number of flips have occurred, yet we are left with an impossible question. Is the lamp on or off? The mechanism underlying our acceptance of supertasks rests on our intuitive understanding of infinite series and limits from calculus, which mathematicians have resolved quite elegantly through the mathematics of convergence, demonstrating that infinite sums can indeed produce finite results when structured properly, as exemplified by the geometric series where 1/2 plus 1/4 plus 1/8 and so forth equals exactly 1. Yet despite this mathematical resolution, something philosophically unsettling persists in our contemplation of supertasks, because while mathematics can tell us that the sum converges to a finite value, it cannot truly answer what happens at the precise moment when the infinite sequence completes itself, nor can it explain how an actual physical process could instantiate infinite discrete actions in finite time without somehow violating the fundamental nature of temporal succession. We have normalized this paradox by relegating it to the realm of pure abstraction, declaring it a mathematical curiosity that does not apply to the physical world, yet we continue to build our understanding of motion, change, and time upon these very mathematical foundations that contain this unresolved tension at their heart, leaving us in a peculiar state where we simultaneously accept that infinite processes can complete finitely and yet resist the implications of that acceptance. Perhaps this discomfort reveals something deeper, that our mathematical frameworks, for all their precision, describe the structure of infinity without capturing the lived experience of temporal passage, and that supertasks ultimately expose a gap between what we can calculate and what we can genuinely comprehend about the nature of reality itself. In this light, supertasks become less a problem to solve and more a mirror reflecting the limits of human cognition itself. We can follow the mathematics to its conclusion, yet something in us refuses to fully inhabit that conclusion, suggesting that perhaps the deepest mysteries of infinity lie not in equations, but in the unbridgeable distance between abstract understanding and concrete intuition. And yet this very gap between calculation and intuition may itself be instructive. In contemplating how we could never actually experience a lamp switching infinitely fast, or a librarian completing infinite tasks, we come to recognize that infinity is not merely a number larger than all others, but a fundamentally different category of existence that our minds, evolved to navigate finite physical reality, may be structurally incapable of fully grasping. Imagine you stand at one end of a room and decide to walk to the opposite wall, a distance that might be 10 meters across the wooden floor beneath your feet. Before you can reach that wall, you must first traverse half that distance, covering 5 meters through space. But before you complete that 5-meter journey, you must first cover half of that remaining distance, which is 2.5 meters. Yet before you accomplish that, you must cover half of 2.5 meters, which is 1.25 meters, and then half of that, and then half of that again, continuing infinitely into smaller and smaller fractions that never quite reach zero, but approach it endlessly like a mathematical asymptote receding forever into the distance. This is Zeno's dichotomy paradox, formulated by the ancient Greek philosopher Zeno of Elea around 2400 years ago, a logical puzzle that suggests motion itself may be impossible because you would need to complete an infinite number of steps before arriving anywhere at all. And since infinity cannot be completed in finite time, the very act of walking across a room becomes logically impossible despite the fact that you do it every single day without hesitation or difficulty. The psychological mechanism that permits this paradox to persist lies in our intuitive understanding of motion, conflicting directly with our mathematical analysis of infinite sequences, creating a cognitive dissonance between what we observe with our senses and what our logical reasoning tells us must be true. We experience continuous motion constantly, yet when we deconstruct that motion mathematically, we encounter this apparently insurmountable problem of infinite divisibility that seems to forbid movement altogether. The paradox has never truly been resolved in the popular imagination, despite centuries of philosophical and mathematical attempts to explain it through the concepts of convergent infinite series, the nature of continuous space and time, and the distinction between potential and actual infinity. Instead, we have simply normalized the contradiction by accepting that both statements appear true simultaneously, that motion is impossible, and yet we move, that an infinite sequence of steps somehow completes itself in finite time through a mechanism we intuitively understand but cannot fully explain, leaving us suspended in the strange space between mathematical impossibility and lived experience. This suspension mirrors the fundamental gap between abstract mathematics and physical reality, a gap that may ultimately reveal more about the limitations of our formal systems than about the nature of motion itself, suggesting that some truths about the world resist complete logical formalization and must instead be simply accepted as features of existence that transcend the reach of pure reason. Perhaps this is why Zeno's dichotomy remains perpetually unsatisfying despite rigorous mathematical solutions, because the paradox ultimately asks not whether motion is possible, but whether our frameworks for understanding reality can ever fully capture what it means to actually exist and move through time, a question that mathematics alone may never adequately answer. Imagine yourself standing in the middle of a modern sports stadium, watching athletes move across the field during a competition, and consider the peculiar problem that Zeno of Elea posed over 2,000 years ago when he observed what he called the stadium paradox, which presents the question of whether motion through discrete spaces is logically possible at all. Picture a runner sprinting from one end of the stadium to the other, and now imagine that we break down this journey not into the familiar continuous flow of movement that we perceive, but rather into an infinite series of discrete positions or finite segments that the runner must pass through in sequence. According to Zeno's formulation, before the runner can traverse the entire length of the stadium, they must first traverse half of it, and before completing that half, they must traverse half of that remaining distance, and before that, they must cover half of whatever segment precedes it, and this process of having continues infinitely backward into ever smaller fractions of space. The logical mechanism at work here involves the concept that an infinite series of actions or distances cannot be completed in finite time, because how could one possibly accomplish an unlimited number of tasks, however small each individual task becomes, within the constraint of a single afternoon at the stadium? Our minds rebels against this conclusion because we witness athletes completing races all the time, we see them cross finish lines, we observe their victory celebrations, yet the mathematical structure of the argument seems ironclad and deeply troubling to those who first encounter it. What makes Zeno's stadium paradox particularly insidious is that it does not rely on our inability to perceive infinitely small distances, as we might dismiss with the dichotomy paradox, but rather it forces us to confront the idea that completing a race requires summing an infinite geometric series, a concept that should, by pure logic, require infinite time to accomplish. We have largely normalized and moved past this paradox through the development of mathematical analysis and calculus, through the understanding that infinite series can indeed converge to finite values, yet the original force of the paradox persists in our intuition, reminding us that our immediate perceptual experience of smooth, continuous motion may be fundamentally at odds with the discrete, quantized nature of reality as described by physics and mathematics at the deepest levels. In modern physics, the paradox resurfaces in unexpected ways. Quantum mechanics suggests that at the smallest scales, space and time themselves may be fundamentally discrete rather than continuous, vindication of Zeno's ancient intuition that motion through indivisible units presents a genuine puzzle about the nature of reality. The stadium paradox thus reminds us that the deepest questions about motion, infinity, and the structure of existence cannot be permanently solved by mathematics alone, but must be confronted anew by each generation as our understanding of the physical world evolves. Imagine a ship that has sailed the seas for centuries, and over time, each wooden plank begins to rot and weaken under the relentless assault of salt water and weather. The sailors, wanting to preserve their vessel and keep it seaworthy, gradually replace each damaged board with a new one of identical shape and material. They replace one plank, then another, until eventually, after many years of this meticulous maintenance, every single original piece of wood that once composed the ship has been removed and replaced with new timber. The ship still floats, still sails, still performs exactly the same function, and everyone continues to call it by the same name, yet materially speaking, not a single atom of the original ship remains. This ancient thought experiment, attributed to the philosopher Thomas Hobbes, but originating from Plutarch's account of Theseus's legendary vessel, forces us to confront a peculiar paradox about identity and continuity. Our minds naturally resist the idea that something can be fundamentally transformed while remaining essentially itself. We possess an intuitive sense that objects possess some kind of persistent essence, some irreducible quality that defines them regardless of their material composition, yet we struggle to articulate what that essence actually is. We might say the ship is defined by its structure, its function, its history, or the continuity of its existence through time, but each explanation creates new contradictions and complications. Perhaps what truly persists is not the physical matter, but rather the unbroken narrative thread of maintenance and care, the continuous human relationship with the object that grants it its identity. Yet we have normalized this paradox so completely in our daily lives that we scarcely notice it. We accept that our own bodies replace nearly all their cells within 7 years, that our personalities and memories transform across decades, that we are fundamentally different people than we were in childhood, and yet we insist upon a continuous self. We speak of preserving historical buildings that have been reconstructed so thoroughly that virtually nothing original remains. We believe our countries maintain their identities despite countless changes in government, borders, and populations. The paradox persists not because we have solved it, but because we have agreed to stop asking the question. Perhaps this is not a flaw in our reasoning, but rather a feature, a necessary fiction that allows us to navigate a world of constant flux by imposing order and continuity where, at the quantum level, there may be none. In choosing to see the ship as whole and unchanged, we are not denying reality, but rather deciding what matters most to us. Not the atoms themselves, but the meaning we collectively agree they hold. And so the Ship of Theseus reminds us that identity is not discovered in the physical world, but rather constructed through our collective agreement to recognize continuity, a recognition that extends far beyond maritime vessels to encompass everything we cherish and claim as our own. In this light, the Ship of Theseus becomes not merely a logical puzzle, but a profound meditation on how we create meaning through persistence and care, suggesting that identity itself is less about what something is and more about what we collectively choose to honor and preserve. Imagine a rotating disk, perfectly rigid and spinning at a constant speed, and as it spins faster and faster, something mathematically peculiar begins to emerge from the very fabric of the scenario. The outer rim of the disk travels at a velocity approaching the speed of light, while the center remains stationary, and according to special relativity, objects in motion experience length contraction along the direction of their movement. This means the outer rim, moving at relativistic speeds, should contract in the direction of its motion, becoming measurably shorter in its circumferential length, yet the radius of the disk, being perpendicular to the direction of motion, should experience no contraction whatsoever. If the circumference contracts while the radius remains unchanged, then the ratio of circumference to radius no longer equals 2 pi, which is the fundamental relationship that defines Euclidean geometry itself. The disk's geometry would have to become non-Euclidean, curved and distorted in ways that seem to violate the very physical structure of space, and yet the disk itself remains rigid and unchanged in our reference frame. This is the Ehrenfest Paradox, named after physicist Paul Ehrenfest, who first formulated it in 1909, and it exposed a deep tension between special relativity and the classical concept of a perfectly rigid body. The psychological mechanism at work here involves our intuitive belief that space is flat and universal, that geometry is absolute and unchanging, and that a physical object like a disk must maintain consistent geometric properties regardless of how fast it spins. We are accustomed to thinking of rigidity as an absolute property, something that either is or is not, but relativity suggests that rigidity itself is an illusion dependent on one's frame of reference. The paradox persists in our understanding of physics not because it remains unsolved, but because its solution requires us to abandon the classical concept of a perfectly rigid body entirely, accepting instead that no material object can be truly rigid when relativistic effects become significant, and that space itself might be curved and relative in ways our everyday experience never prepares us to comprehend. The resolution ultimately points toward general relativity, where Einstein showed that rotating reference frames experience spacetime curvature equivalent to a gravitational field, meaning the disk's geometry genuinely becomes non-Euclidean not as a paradox, but as a prediction confirmed by the theory itself, transforming what seemed like an impossibility into a profound insight about the nature of space, time, and gravity. The disk becomes a microcosm of the universe itself, a spinning laboratory where the rules of Euclidean geometry break down and reveal that space is not a passive container, but an active participant in physical reality, responsive to motion and energy in ways that demand a complete reimagining of what we mean by rigid, flat, or absolute. This realization, born from a simple thought experiment about a spinning disk, became one of the conceptual bridges that carried physics from the flat, absolute spacetime of Newton into the curved, dynamic universe of Einstein, where even our most fundamental assumptions about geometry and rigidity must be questioned and ultimately reconceived. Imagine a theoretical device that exploits the properties of faster-than-light particles, hypothetical entities known as tachyons that would travel backward through time by necessity of their very nature. And consider what would happen if two such particles could be entangled and separated across space in such a way that they could carry information between 2 points, with one receiver positioned in the past relative to the other sender, creating a paradoxical communication channel where the message arrives before it is sent, violating our fundamental understanding of causality and the arrow of time itself. This is the Tachyonic Antitelephone, a thought experiment first seriously explored by physicist Gregory Benford and his colleagues, a device that would not merely bend the rules of temporal mechanics, but would shatter them entirely, allowing information to flow backward through the stream of moments we experience as the inexorable forward march of existence. The psychological mechanism that makes this paradox so compelling is our deep intuition that causes must precede effects, that the present moment is where agency originates and the future is where consequences unfold. Yet here we encounter a scenario where a message could be received, acknowledged, and responded to before the original sender has even decided to transmit it, creating a causal loop that loops back on itself with no clear origin point, no moment where the sequence truly begins. What makes this paradox particularly unsettling is that it does not require us to abandon physics entirely, only to accept that particles moving faster than light could exist, a notion that sits at the edge of established theory rather than firmly outside it. And yet this borderline possibility collapses our sense of temporal order with elegant simplicity. We have internalized the notion that information flow defines time's direction, that causality is the skeleton upon which reality hangs, and the antitelephone suggests that this skeleton might be far more fragile than we realize, that the very concept of before and after might be merely conventional rather than fundamental, something our minds impose upon a universe that operates according to different rules entirely. Perhaps this is why the antitelephone haunts us so persistently in science fiction and theoretical physics alike. It represents not merely a technical problem to be solved, but a fundamental challenge to the narrative structure of consciousness itself, the story we tell ourselves about being agents moving through time rather than observers of a block universe where all moments exist simultaneously and equally real. If we could receive a message from our future self warning us away from a choice we have not yet made, we would face not merely a logical paradox, but an existential one. The collapse of the illusion that our decisions are truly our own, that the future remains genuinely open rather than already written into the fabric of space-time, waiting only for our present moment to catch up. And yet this ultimate fear, that we are merely actors reading from a script written before our birth, may be precisely why we find ourselves drawn to imagine such devices, compelled to articulate the paradox that our rational minds cannot quite dismiss. as if by naming the impossibility we might somehow reclaim agency in a universe that may have already decided our fate. Imagine standing in a laboratory where the present moment reaches backward through time to reshape the past, where an effect precedes its cause by seconds or minutes or even longer, where the decision you make today somehow influences an event that already happened yesterday, creating a loop of causation that flows in both directions simultaneously. This is the essence of retrocausality, a phenomenon that challenges our most fundamental understanding of how cause and effect should operate in a universe governed by the arrow of time. In quantum mechanics, particularly in experiments involving delayed choice observations, physicists have observed situations where measuring a particle in the present appears to determine the particle's behavior in the past, as though the future measurement sends information backward through time to influence what has already occurred. The delayed choice quantum eraser experiment demonstrates this with startling clarity, where researchers can observe a particle taking one path or multiple paths depending on measurements made after the particle has already traveled, suggesting that the present choice retroactively determines the past reality. Our minds struggle with this concept because we are temporally bound creatures, experiencing time as a strictly linear progression from past through present into future, never imagining that the order could reverse or tangle upon itself. Yet despite the logical impossibility that retrocausality represents to our everyday intuition, physicists continue to detect these patterns in the quantum realm, suggesting that at the smallest scales of reality, causation might not be a simple arrow, but rather a complex web where influences can flow backward as easily as forward. We have normalized this paradox by relegating it to the quantum world, treating it as a peculiarity of subatomic particles rather than acknowledging what it truly implies, that causation itself might be a human construct superimposed upon a universe that operates according to different principles entirely, where time and sequence are far less fundamental than we have assumed. If we accept that the universe does not inherently care about our temporal distinctions, then perhaps the future is no less real or influential than the past, and every moment exists simultaneously in a four-dimensional tapestry where causation is merely the pattern we perceive when moving through it in one direction. This realization transforms retrocausality from an impossibility into an inevitability, a natural consequence of a cosmos far more interconnected and indifferent to our sense of sequence than we have ever dared to imagine. Perhaps this is why the universe permits quantum entanglement across vast distances and why probability waves collapse into certainty only upon observation, not because reality bends to our measuring instruments, but because in a truly nonlinear cosmos, the act of observing and the event observed are separated only by our crude perception of time, 2 points on a circle pretending to be points on a line. Imagine a physicist named Wigner who sends his friend into a laboratory to perform a quantum measurement on a particle, and while the friend is inside conducting the experiment, Wigner remains outside observing only the laboratory door, unable to see what happens within. According to the standard interpretation of quantum mechanics, the moment the friend measures the particle, the wave function collapses and reality becomes definite. So from the friend's perspective inside the lab, the particle has a determined state. Yet from Wigner's external perspective, until he receives information about what his friend observed, the entire laboratory, including his friend, remains in a superposition of states, existing in multiple measurement outcomes simultaneously. This creates a logical paradox where two observers at different vantage points cannot agree on when or whether the wave function actually collapsed, suggesting that reality itself depends on the observer's position and what information they possess. The mechanism underlying this puzzle reveals something profoundly unsettling about the nature of observation in quantum mechanics. Consciousness and information create reality rather than merely revealing pre-existing facts about it. When the friend looks at the measurement device, they know the outcome, but Wigner, standing outside, must still treat both possible outcomes as existing in superposition until someone tells him the result. This means that the same event is simultaneously real for one observer and uncertain for another, implying that objective reality cannot exist independently of observation, or that the universe branches into different states depending on who is doing the measuring. We have normalized this interpretive nightmare by treating it as merely a philosophical curiosity, a thought experiment that reveals the strangeness of quantum mechanics without demanding we actually change how we think about time, causality, or the nature of existence itself. Yet the paradox persists in textbooks and lectures, acknowledged and then set aside, never truly resolved, suggesting that somewhere deep within our understanding of reality, something fundamental remains broken or incomplete, waiting for a framework that can explain how observation creates certainty while leaving us in eternal uncertainty about what observation truly is. Perhaps the deepest irony is that Wigner's friend forces us to confront the possibility that there is no objective fact of the matter about reality's state, until information propagates and observers synchronize their knowledge, meaning the universe itself might be fundamentally incomplete, not because we lack information, but because information and observation are not secondary features layered atop reality, but rather the very substance from which reality is constructed. If this is true, then the question, what is the state of the particle, becomes meaningless outside the context of a specific observer's interaction with it, and we are forced to accept that quantum mechanics is not describing a world that exists independently of measurement, but rather a world that only crystallizes into definite form through the act of observation itself. A vision so radical that most physicists prefer to simply calculate predictions and avoid asking what reality actually is. Imagine a physicist travels backward in time with the explicit intention of preventing their own birth by eliminating their grandmother before she conceives the physicist's parent. Yet at the precise moment the physicist raises a weapon, their hand inexplicably trembles, they slip on a hidden object, or the weapon malfunctions in such a way that the grandmother remains unharmed and continues her life exactly as it occurred in the original timeline, thus preserving the very chain of events that led to the physicist's existence and their journey backward through time in the first place. This is the essence of Novikov self-consistency, a principle proposed by Russian astrophysicist Igor Novikov, which suggests that if time travel is possible, then the universe must naturally enforce a kind of cosmic consistency where any action taken by a time traveler becomes an integral and unchangeable part of history, and therefore paradoxes cannot arise because the timeline actively resists or redirects any attempt to create a logical contradiction. The mechanism at work here involves a fundamental reorientation of how we understand causality and free will within a closed temporal loop, where the universe appears to possess an almost prescient quality, subtly manipulating probabilities and circumstances so that outcomes align with what has already occurred, creating a kind of deterministic framework wherein every event, including the time traveler's journey and their actions within the past, is always meant to happen exactly as it did. What makes this concept so psychologically intriguing is that it removes the paradox entirely by suggesting that true free will might be an illusion within such a framework, or alternatively, that free will operates on a level that simply cannot create the contradictions we imagine, because the moment a time traveler acts, they are not creating something new, but rather fulfilling a predetermined role in a self-consistent narrative that has always been true. We have normalized this idea within science fiction and theoretical physics discussions by accepting that perhaps reality is more subtle and deterministic than our intuitions suggest, and that the universe, if it permits backward time travel at all, must have already solved the paradox problem through mechanisms we scarcely understand, leaving us to contemplate whether genuine choice exists even in our own forward-moving present. Yet this raises a haunting question. If we cannot change the past through time travel, then perhaps we cannot truly change anything at all, and every decision we believe we freely make is merely the universe's elegant solution to maintaining its own internal consistency, a possibility that transforms time travel from a physics problem into a profound meditation on the nature of agency itself. In this light, the grandmother paradox becomes not a logical trap, but a koan, a puzzle that dissolves the moment we stop assuming the time traveler possesses genuine alternatives, and instead recognize that their fumbling hand and the slipped footstep were never accidents at all, but rather the universe's predetermined mechanism for preserving itself, suggesting that causality operates less like a branching tree of possibilities and more like a tapestry already woven, where every thread, including our sense of free choice, was always part of the design. Imagine standing at a crossroads in your life, facing a decision that feels impossibly consequential, and notice how your mind instinctively splits into parallel tracks, each one playing out the consequences of different choices with vivid intensity. You picture yourself taking the job in the distant city, and simultaneously you picture yourself staying home, and your consciousness seems to occupy both scenarios with equal weight and detail, as though part of you is genuinely living through each possibility at once. This is the many worlds escape, a subtle cognitive phenomenon where we use quantum mechanical theory as a psychological permission slip to avoid the gravity of our own choices. The mechanism operates on a seductive logical foundation. If the many worlds interpretation of quantum mechanics is true, then every decision we make causes reality to split, with one version of us experiencing outcome A while another version experiences outcome B, meaning no choice is truly irreversible because all versions of us exist somewhere in the multiverse. This thinking provides profound psychological relief because it transforms the weight of finality into the comfort of simultaneity, allowing us to convince ourselves that we are not truly choosing to abandon any path, but rather that all paths are being explored by some version of ourselves across the infinite branches of reality. We lean on this framework during moments of genuine uncertainty, telling ourselves that the version of us who took the lesser option is still out there, still living, still valid, which seems to diminish our responsibility for the consequences of our actual decision in this actual timeline. The paradox deepens when we recognize that this framework, whether scientifically valid or not, has become normalized in contemporary psychology and popular philosophy, woven into self-help rhetoric and meditation practices that encourage people to release attachment to unchosen outcomes by imagining their existence in parallel universes. Yet this normalization obscures something essential. We only experience one timeline, we only live one life, and the many worlds interpretation, while theoretically elegant, offers us no actual access to the outcomes we did not choose, no way to verify that those other versions are thriving, no mechanism by which their distant flourishing can meaningfully comfort us in our singular present. We have adopted the language of quantum mechanics not because we truly believe in the multiverse, but because it provides an excuse to treat our irreversible choices as if they were somehow reversible, as though imagining the path not taken were equivalent to actually taking it. And so we sit with our choice, half present in our actual life, the other half of our attention perpetually haunting the branch we did not take, until the weight of the unchosen path becomes heavier than the path we are actually walking, and we find ourselves living as ghosts in our own singular timeline, mourning possibilities that were never ours to mourn. The cruelest irony is that this escape hatch we've built for ourselves, this imaginary comfort of infinite versions living infinite lives, ultimately prevents us from fully inhabiting the one life we actually have, from investing our whole self in the singular branch where we must live and die, where our choices matter precisely because they are irreversible and ours alone. Imagine a universe that exists outside of time, where there is no clock ticking forward, no past flowing into future, no moment of now that separates what was from what will be, and yet within this timeless void, every possible configuration of matter and energy somehow exists simultaneously in a mathematical superposition that defies our ordinary intuition about causality and sequence. The Wheeler-DeWitt Equation, formulated in the 1960s by physicists John Wheeler and Bryce DeWitt, attempts to describe the quantum state of the entire universe as a single wave function that depends on the spatial geometry of space, but conspicuously does not depend on time itself, suggesting that time emerges only as an approximation we impose on a fundamentally atemporal reality. Within this framework, the universe does not evolve through time in the way our everyday experience suggests. Rather, all moments of the universe's history exist as static configurations within a higher dimensional space, and our perception of temporal flow becomes merely a subjective experience arising from our limited perspective within the system itself. The psychological mechanism driving our continued acceptance of this paradox, despite its profound weirdness, stems from our ability to compartmentalize, to hold classical intuitions about time in one mental box while simultaneously entertaining quantum descriptions in another, never fully reconciling how a universe without time can produce conscious observers who experience nothing more fundamentally than the relentless forward march of moments. We have somehow normalized this contradiction through mathematical language, allowing equations to express what words cannot comfortably contain, and in doing so we have created an intellectual space where the equation becomes more real than the phenomenon it supposedly describes. Yet we continue living as if time flows genuinely forward, making plans for tomorrow, remembering yesterday, experiencing the irreversible arrow of causality, all while accepting on some intellectual level that these experiences might be illusions cast by an underlying timeless mathematical structure that the Wheeler-DeWitt equation hints at but cannot fully explain. Leaving us suspended between two incompatible visions of reality, that somehow coexist in the contemporary physics landscape. The problem of time in quantum gravity remains unsolved precisely because we lack the conceptual vocabulary to describe what timelessness means when applied to a universe that must somehow give rise to beings capable of asking the question in the first place. A circularity that suggests our current mathematical frameworks may be fundamentally incomplete, missing some essential ingredient that would dissolve the paradox rather than merely defer it. Perhaps what we are missing is not a better equation, but a fundamental shift in how we conceptualize the relationship between the observer and the observed. A recognition that time may not be a property of the universe itself, but rather an artifact of the measurement process, emerging only when a conscious system like ourselves attempts to parse the infinite simultaneity of quantum possibility into the sequential narrative of lived experience. Consider that at this very moment, you are experiencing what feels like the present, this exact instant where consciousness meets reality. Yet the moment you acknowledge it, that present has already become the past, and a new present has taken its place, meaning you are always living in a state of perpetual lateness to your own existence, forever chasing a moving target that by definition cannot be caught because the act of observing it changes what you are observing. Neuroscientists have discovered that your brain requires approximately 80 milliseconds to process sensory information, which means the present moment you experience is not actually present at all, but rather a carefully reconstructed memory of something that happened 80 milliseconds ago, a neural illusion so convincing that you mistake it for real-time experience. Yet you move through the world as if you're genuinely present in the now, when in fact you are always living slightly in the past. Experiencing a phantom present that is nothing more than your brain's best guess at what reality looks like. The mechanism at work here involves a fundamental disconnect between physical time and experiential time. Physics tells us that time is simply another dimension in the fabric of spacetime, no more special or directional than length or width. Yet consciousness insists that time flows inexorably forward from past to future, creating an arrow that physics cannot actually account for, a psychological projection that we have layered onto the universe despite finding no evidence that time truly moves in any direction whatsoever. And yet we have built entire civilizations around this assumption. We plan for futures, we remember pasts, we create meaning through narrative continuity, all while operating under the assumption that this present moment is real and substantial, that it matters, that we can actually inhabit it, when logic and neuroscience both suggest that the present is merely the razor-thin boundary between two directions of time that may themselves be equally real, equally past, or equally non-existent. And that your sense of now is simply a trick your brain plays to make sense of a universe where time may not actually exist at all as you experience it. Consider that this illusory present is the only moment in which you can actually live, decide, or act, the only point at which your will seems to matter, yet it may be nothing more than a necessary fiction, a cognitive necessity that allows a time-bound creature like yourself to function in a universe that may be fundamentally timeless, suggesting that meaning itself might depend entirely on embracing a beautiful lie about the nature of reality. If this is true, then perhaps the greatest paradox is that you must live as if time is real and directional, as if your choices matter and your future is open, even while suspecting that both may be illusions, meaning that consciousness itself may be nothing more than the experience of navigating a deterministic universe while maintaining the necessary delusion of free will within a present that never truly arrives. Imagine a physicist proposing that everything that has ever existed exists right now, simultaneously frozen in an eternal landscape where past, present, and future all coexist as static configurations of matter and energy, and that what we perceive as time is merely our consciousness moving through this unchanging terrain like a traveler walking through a geography that never alters. This is the essence of Julian Barber's concept of Platonia, named after Plato's realm of eternal forms, a theoretical framework suggesting that the universe does not evolve through time, but rather exists as an infinite collection of possible configurations, each one representing a complete snapshot of reality at what we call a different moment. In this vision, there is no flow of time, no genuine passage from past to future, but only an array of static three-dimensional shapes geometrically arranged in a high-dimensional space, and our subjective experience of moments succeeding one another is nothing more than a peculiar ordering we impose on these configurations as our awareness moves through them. The mechanism underlying this counterintuitive idea rests on solving fundamental equations in physics that describe the universe's behavior, equations which, when properly analyzed, contain no explicit reference to time as a flowing parameter, but instead yield timeless solutions that exist independent of any temporal framework, suggesting that time might be an emergent property of consciousness rather than a fundamental feature of reality itself. Yet despite the mathematical coherence of this proposal and the serious consideration it receives from theoretical physicists, we continue to construct our entire civilization around the assumption that time genuinely flows, that causes precede effects in a meaningful way, that we make choices that shape futures not yet written, and we organize our lives, our laws. Our moral judgments around this lived experience of temporal directionality, without acknowledging that the underlying physics might suggest we are navigating a static landscape of eternally coexisting moments, rather than genuinely moving into an open future. And this persistent gap between our phenomenological experience and what our deepest theories propose about the nature of reality remains one of the most disorienting paradoxes of human existence. One we have learned to ignore not through resolution, but through the simple act of not thinking about it too carefully. Perhaps this is why we instinctively recoil from the implications of Platonia, not because the mathematics is wrong, but because accepting it would require us to fundamentally restructure how we understand responsibility, hope, and the very meaning of being alive, transformations so radical that our minds rebel against them, even as our equations seem to whisper that they might be true. And yet perhaps there is a strange comfort in this vision too, the thought that every moment of joy, every instant of love, every achievement and discovery that has ever occurred remains eternally preserved in Platonia's vast landscape, not lost to the forward march of entropy, but held in perpetuity as a permanent feature of reality's geometry, immune to decay or forgetting. Consider the revolutionary proposition offered by physicist Carlo Rovelli, whose work suggests that time, as we experience it, might be nothing more than an elaborate illusion born from our particular perspective within the universe. In our everyday existence, we move through what feels like a continuous river of moments, each flowing predictably from past through present toward future, and we construct our entire lives around this seemingly fundamental truth, building calendars and clocks, scheduling appointments and planning decades ahead, organizing society itself into temporal hierarchies where punctuality becomes virtue and lateness becomes transgression. Yet when Rovelli examines the deepest laws of physics, examining quantum mechanics and general relativity at their most fundamental levels, he discovers something profoundly unsettling. The laws that govern the universe at its most basic level contain no arrow of time, no preferred direction, no inherent distinction between forward and backward, suggesting that at the most fundamental layer of reality, all moments might exist simultaneously in a kind of eternal present where nothing truly becomes or passes away. The mechanism underlying this perspective emerges from recognizing that time's apparent flow might be generated by our ignorance and our thermodynamic position within the universe, by the fact that our brains construct narratives and memories, creating a sense of progression from disorder to order, from uncertainty to certainty. A directional feeling that emerges not from objective reality, but from the limitations of our knowledge and our particular vantage point within a vast cosmos, indifferent to our sense of before and after. What remains extraordinary is how thoroughly we have normalized this fundamental disconnect between what physics tells us about reality and how we experience existence moment to moment, how we continue to rush through days and agonize over the future and mourn the past, how we remain trapped within this temporal narrative even when confronted with the possibility that we might all be frozen in an eternal landscape where time itself is merely a story our minds tell themselves about the universe. A comfortable fiction that persists because abandoning it would require us to rebuild not just our physics, but our entire understanding of meaning, memory, and mortality itself. Yet perhaps this very resistance reveals something essential about consciousness itself. That meaning requires narrative, that a mind capable of love and loss and hope cannot inhabit a truly timeless universe, and that our insistence on time's reality might be less an error of perception than a necessary prerequisite for being human at all. In this light, the question becomes not whether time is real or illusory, but whether the distinction itself matters, whether a universe that permits consciousness to experience duration, to remember and anticipate, to forge connections across moments, has already answered the deepest question about time's necessity, regardless of what the equations say. For Rovelli himself, this paradox becomes a kind of intellectual humility. Rather than declaring time definitively real or unreal, he invites us to sit with the discomfort of not knowing, to recognize that our deepest scientific insights might ultimately be asking not, what is time, but what are we that we experience it? Consider the peculiar experience of sitting in a room that gradually grows warmer throughout the afternoon, and notice how your perception of time seems to stretch and elongate as the temperature rises, making each moment feel heavier and more extended than it actually is. While conversely, when you enter a cold environment, time appears to compress and accelerate, moving faster than your watch suggests it should. A phenomenon that has led some theoretical physicists and cognitive scientists to propose what they call the thermal time hypothesis, which suggests that our subjective experience of temporal flow may be directly coupled to the thermodynamic state of our bodies and environment rather than being an independent dimension of reality. In practical terms, this means that when your metabolic processes accelerate due to increased ambient temperature, your brain's internal clock runs faster in an absolute sense, causing external time to feel dilated and slow, whereas when your body cools down, your metabolism decreases, your internal clock slows, and external time appears to rush past you. The mechanism operates through a cascade of physiological responses beginning with thermoregulation, where your hypothalamus works to maintain homeostasis, triggering increased neural activity and biochemical reactions when heat rises, which in turn accelerates your subjective experience of duration because your conscious mind is processing more individual moments per unit of external time. This is not merely psychological distraction or cognitive bias, but rather a genuine alteration in the rate at which your nervous system samples and processes reality, making thermal conditions not just a background variable in human experience, but potentially a fundamental driver of temporal perception itself. Yet despite the mounting evidence that temperature profoundly shapes how we experience time, we continue to treat thermal comfort and temporal experience as completely separate domains, neither adjusting our expectations of how long tasks should take based on ambient temperature, nor recognizing that the very fabric of our moment-to-moment consciousness is woven from the thermodynamic processes occurring within our cells. Allowing this deep truth about the constructed nature of time to persist silently beneath our awareness, shaping our experience while remaining largely invisible to our conscious reflection. If you were to pay deliberate attention to this phenomenon, timing how long a task feels during a sweltering summer afternoon versus a crisp autumn morning, you might begin to notice that your sense of duration fluctuates not randomly, but in direct proportion to thermal conditions, suggesting that learning to recognize these patterns could offer a subtle but powerful tool for reclaiming agency over your own temporal experience. Transforming time from something that simply happens to you into something you can partially modulate through conscious awareness of your body's thermodynamic state. Imagine a universe without time, where nothing moves, nothing changes, and no event ever follows another in sequence, yet somehow order and causality emerge from the mathematical structure itself through the perspective of an observer embedded within it. This is the central premise of the Page-Wootters Mechanism, a theoretical framework developed by Don Page and William Wootters in the 1980s, which suggests that time is not a fundamental feature of reality, but rather an emergent property that arises from entanglement between a system and an observer within a timeless universe. In this conception, the entire cosmos exists as a single, static quantum wave function, a frozen four-dimensional block that contains all possible configurations simultaneously, and what we experience as the passage of time is actually our consciousness correlating with different portions of this eternal mathematical structure, creating the illusion of sequential events and causal progression. The mechanism works by proposing that if you choose any subsystem of the universe to act as a clock, that clock becomes entangled with all other systems, and from the perspective of any observer correlated with that clock, other systems appear to evolve in time according to the clock's internal state, even though nothing is actually moving or changing in the external mathematical reality. What makes this proposal so profoundly unsettling is that it suggests the entire concept of temporal flow, the sensation that moments emerge from the future and disappear into the past, the feeling that we are moving through time toward tomorrow, might all be cognitive constructs generated by how our brains correlate with particular quantum states within a timeless whole. The psychological mechanism supporting our acceptance of this paradox despite its radical implications, appears rooted in our incapacity to truly perceive reality outside of temporal experience. Since our brains are themselves evolved to process information sequentially, to predict futures and remember pasts, making a timeless universe almost impossible to genuinely conceptualize even when we accept its mathematical validity. We have normalized the idea that time might be emergent rather than fundamental through decades of exposure to relativity theory and quantum mechanics. Yet we continue to live and act as though time flows in only one direction, as though causality requires temporal sequence, seemingly unable to bridge the gap between intellectual understanding and phenomenological experience, between the mathematics that suggests time is an illusion and the lived reality in which we are always, inevitably, moving forward into what we call tomorrow. Perhaps this is why the Page-Wootters mechanism remains largely confined to theoretical physics journals rather than reshaping how we navigate everyday life. Because accepting a timeless universe would require us to simultaneously hold two contradictory models of reality in mind, one for mathematics and one for meaning, and human consciousness may simply lack the cognitive architecture to genuinely live according to both at once. Yet perhaps this cognitive limitation is not a flaw but a feature, a necessary scaffolding that allows us to function meaningfully within a universe whose deepest nature remains fundamentally indifferent to whether we perceive it as flowing or frozen, temporal or timeless. Imagine two particles that have become quantum entangled, meaning their states are mysteriously linked across any distance, even across the universe itself, in a way that Einstein famously called spooky action at a distance. And when you measure one particle and find it spinning clockwise, the other instantly becomes counterclockwise, no matter how many light years separate them. And this phenomenon creates a peculiar problem for our understanding of time, because the correlation between these particles appears instantaneous, suggesting that information or causality moves faster than light, which should be impossible according to relativity, yet the mathematics works perfectly and experiments confirm it happens repeatedly, and physicists have verified this countless times across decades of research, finding no violation of physical laws, even though the mechanism seems to defy the very temporal structure we believe governs reality. The psychological mechanism that allows us to accept this impossibility rests on a subtle sleight of hand we collectively perform, where we tell ourselves that no usable information travels faster than light, that the correlation is merely statistical rather than causal, that time still flows forward even if quantum mechanics seems indifferent to temporal direction. And we have become so comfortable with the paradox that we simply categorize it as one of those strange quantum things that normal reality does not need to explain, tucking it away into a specialized domain where different rules apply. Yet the persistence of this paradox, despite decades of scrutiny, suggests something deeper about time itself, that perhaps our insistence on a universal flow of moments from past to future is a convenient fiction we have imposed on a universe that genuinely does not care about temporal order at all. And the fact that we continue to teach quantum entanglement alongside classical relativity without resolving the fundamental tension between them indicates we have normalized the idea that contradictory truths can coexist peacefully in our physical theories, accepting this cognitive dissonance as simply the cost of modern physics rather than as a sign that time might be something we have fundamentally misunderstood from the very beginning. If time is not fundamental but emergent, a useful scaffolding our minds construct to navigate causality, then entanglement reveals the universe's true language, one where past and future are not separate territories but a single landscape of correlations that our sequential consciousness simply experiences in installments, moment by moment, forever unable to see the whole pattern at once. And perhaps this is why we find ourselves perpetually surprised by quantum mechanics, not because the universe is truly strange, but because we are watching a timeless tapestry through the narrow slit of sequential awareness, mistaking the limitations of our perception for the limitations of reality itself, forever unable to step outside the moment to see that entanglement is not an exception to time, but rather time's true nature finally revealing itself in the laboratory. In theoretical physics, there exists a concept that attempts to quantify the smallest possible unit of time itself, a particle-like entity called the chronon, theorized to be the fundamental indivisible grain from which all temporal experience is constructed, much like atoms are the building blocks of matter, and this idea emerges from the deep human need to make time tangible, measurable, and ultimately graspable in the same way we have learned to grasp space and energy, and all the other forces that seem to govern existence. The chronon represents an attempt to answer a question that has plagued scientists and philosophers alike. If time flows continuously, then what is the smallest interval during which something can actually happen? And if there is no smallest interval, does that mean infinite events could occur in a single second? Or does it mean that time itself must be quantized, divided into discrete packets rather than the smooth continuum it appears to be? The psychological mechanism at work here stems from our fundamental inability to truly perceive time as anything other than something that must have structure, must have components, must be built from something smaller, because we have had such remarkable success in reducing all other phenomena to their constituent parts, from matter to molecules to atoms to subatomic particles, that the prospect of time being genuinely irreducible, genuinely continuous and infinitely divisible creates a profound cognitive discomfort that demands resolution. We have projected this reductionist success onto time itself, assuming that because everything else can be broken down further and further, time too must eventually reach a bottom, must reach a final unit beyond which division becomes impossible. And this assumption has persisted through decades of theoretical development, despite the fact that there is no experimental evidence whatsoever for the existence of chronons. And despite the fact that our most successful frameworks for understanding the universe, quantum mechanics and general relativity, contain no reference to chronons or any fundamental unit of time at all. Yet physicists continue to explore chronon theories, continue to calculate what properties such particles might possess, continue to search for evidence of temporal quantization in their experiments, revealing how deeply we remain committed to the idea that time must be like everything else we have successfully understood, reducible and countable and fundamentally composed of something, even though time remains profoundly different from space and matter. Even though the very concept of a chronon might be a category error, a misapplication of our most successful reduction strategy to a dimension of reality that simply does not obey the same rules. Perhaps this is the deepest lesson the chronon teaches us, that our most powerful tool for understanding nature, the reductionist method, may itself be a projection of human cognitive needs rather than a mirror of reality's true structure, and that some phenomena may resist our attempts at decomposition not because we haven't looked hard enough, but because they genuinely exist at a level of analysis where reduction itself becomes a category mistake. Imagine standing at the edge of the smallest possible measurement of time, a threshold so infinitesimally brief that it represents approximately 5.39 times 10 to the negative 44 seconds, a duration so compressed that it renders the very concept of before and after meaningless, and this boundary is called Planck time. Named after physicist Max Planck, who first calculated it as the smallest unit of time that could theoretically exist within our universe before quantum gravity effects would make our current laws of physics completely break down. At this scale, time itself ceases to be a smooth, continuous river and instead becomes something far stranger, a frothy, foaming quantum landscape where particles pop in and out of existence and causality becomes uncertain. Yet here is the peculiar paradox. We cannot actually measure anything at this scale, we cannot observe it, we cannot prove that time genuinely stops being divisible at this point, and yet physicists accept it as a fundamental floor, a hard boundary beyond which time itself may not exist in any meaningful way. The psychological mechanism underlying this acceptance is our deep need to find absolute limits and foundations, to believe that beneath the complexity of reality there must be something solid and irreducible, something we can point to and say, here, this is the smallest piece. And this gives us comfort because it suggests that chaos does have a boundary, that infinity does not extend infinitely in all directions, yet the Planck time remains purely theoretical. A mathematical prediction rather than an observed phenomenon. We have normalized this invisible frontier despite the fact that we cannot see it, measure it directly, or even be certain it truly exists as a discrete boundary rather than merely a point where our equations stop working. And in doing so we have created a floor for time that we accept on faith rather than evidence, a paradox where the smallest measurable unit of time is so small it may never be directly measurable at all, leaving us with a foundation so abstract that it barely seems like a foundation at all, yet we build our understanding of temporal reality upon it anyway. And perhaps this is the deepest irony of all, that our most rigorous scientific framework rests ultimately upon a theoretical bedrock we can never touch, forcing us to accept that the universe may be fundamentally unknowable at its smallest scales, Yet we continue building our theories upward from this invisible foundation anyway, trusting in mathematics rather than experience, in abstraction rather than observation. Perhaps this is why Planck time haunts physicists in a way that other theoretical limits do not, because it forces us to confront the possibility that reality itself might be fundamentally discrete rather than continuous, that the universe operates on a hidden grid we can never quite perceive, and that our entire edifice of physics might be built upon assumptions about the nature of time that are ultimately untestable and possibly wrong. Yet perhaps this uncertainty is not a weakness but a feature, a reminder that science progresses not by discovering absolute truths, but by building increasingly sophisticated frameworks for asking better questions, and that the floor beneath Planck time may ultimately matter less than our willingness to keep searching for what lies beyond our current understanding. Consider the physicist Stephen Hawking's concept of imaginary time, a mathematical construct that emerges from the equations of quantum mechanics and general relativity when we rotate the time dimension into the complex plane of mathematics, treating it as if it were a spatial dimension rather than a temporal one. In this framework, time becomes indistinguishable from the three spatial dimensions we navigate through physical reality, suggesting that our entire universe might operate according to laws where past, present, and future exist simultaneously as a four-dimensional block that does not actually flow or progress at all. The mathematical elegance of imaginary time allows physicists to resolve certain paradoxes in quantum gravity that plague conventional models, particularly around black holes and the conditions at the moment of the Big Bang, where the traditional laws of physics break down entirely and become meaningless. When imaginary time is applied to these extreme scenarios, the infinities and infinitesimals that would otherwise destroy our equations suddenly vanish, replaced by smooth, continuous solutions that make physical sense and suggest a universe governed by symmetry and mathematical harmony rather than the arrow of time that dominates our conscious experience. Yet despite this profound mathematical insight suggesting that time, as we perceive it, might be merely an artifact of how consciousness interprets a static four-dimensional reality, we continue living as though time genuinely moves forward, as though the future truly does not yet exist, and the past has genuinely ceased to be. We experience an undeniable subjective flow, a sense that moments transition from future to present to past in a genuine progression that feels absolutely real and undeniable from within our own perspective. And this felt experience persists even when we intellectually grasp that imaginary time might be more fundamental than the temporal dimension we inhabit. The paradox deepens when we consider that imaginary time exists only in mathematical equations, in the abstract language humans created to describe reality, and yet the equations suggest that this invisible, unperceivable dimension might be more real and more true than the very experience of temporal flow that defines human consciousness and subjective existence itself. Perhaps this is the deepest mystery of all, that the most accurate description of reality emerges from a mathematical dimension we cannot perceive, suggesting that truth itself may exist in realms forever beyond the reach of human sensation, accessible only through the abstract symbolic language of mathematics that somehow, mysteriously, corresponds to the structure of existence itself. This gap between mathematical truth and perceptual reality might explain why consciousness itself remains so enigmatic. Perhaps awareness evolved not to perceive reality as it fundamentally is, but to navigate the practical present moment, making the subjective experience of time's flow and adaptive fiction more useful for survival than the timeless, four-dimensional truth that imaginary time reveals lurking beneath it. Consider the moment when Stephen Hawking and James Hartle proposed something that would fundamentally reshape how we understand the origin of the universe itself, a concept they called the no-boundary proposal, which suggests that the universe has no beginning and no end, not because it extends infinitely backward and forward through time, but because time itself, in the earliest moments of cosmic history, becomes indistinguishable from space in a way that renders the very question of what came before the universe entirely meaningless. In this framework, asking what happened before the Big Bang is like asking what lies north of the North Pole, a question that seems reasonable on its surface, but dissolves the moment you examine its logical structure, because there is no direction called north beyond that geographical boundary, and similarly, there is no time before the boundary of the universe, because time only emerges as a distinct dimension within the universe itself. The proposal draws from quantum mechanics and general relativity, disciplines that have already forced us to abandon our intuitions about causality and sequence, yet we persist in imagining time as a river flowing from past to future, a fundamental stream in which the universe exists like a boat traveling downstream, and we struggle viscerally with the notion that time might be merely a feature of the universe rather than a container holding it. What makes this paradox particularly disorienting is that our entire conceptual framework, our language, our neurology, and our basic sense of self are all constructed around the assumption that time flows in one direction, that causation requires a cause to precede an effect, that the future exists as something not yet determined. And yet the mathematics of the no-boundary proposal suggests these intuitions might be profound misconceptions about the structure of reality itself. We have normalized temporal thinking so completely that we cannot even conceive of existence without it, cannot imagine a state of being where the distinction between before and after, between cause and effect, between potential and actual, simply does not apply, and this cognitive limitation persists despite decades of physicists explaining these concepts, despite the predictive success of these models. Because our evolved minds are fundamentally unprepared to release the narrative structure that time provides. Yet perhaps this very difficulty, this stubborn resistance of our intuition, is itself informative, suggesting that we are glimpsing something genuinely alien to the structure of conscious thought, a glimpse of reality that operates according to principles so foreign to our embodied experience that no amount of mathematical elegance can fully domesticate it into understanding. And so we find ourselves in the peculiar position of having constructed a map of reality that our minds cannot fully inhabit, armed with equations that predict the universe's behavior with stunning precision while remaining forever estranged from genuine comprehension. As if we have learned to speak a language whose grammar describes truths we are neurologically incapable of believing. When we contemplate the moment of the Big Bang, we find ourselves asking a question that seems innocent enough on the surface, but becomes deeply paradoxical the moment we examine it closely. What came before it? Our minds instinctively reach backward through time, imagining some previous state, some cosmic preparation, some condition that existed prior to the universe's explosive beginning. Yet the more carefully we consider this question, the more we realize we are asking something that may be fundamentally impossible to answer or even properly conceive. The Big Bang Theory, as currently understood by modern cosmology, describes not merely the beginning of matter and energy, but the beginning of spacetime itself, the very fabric through which causality flows and through which we experience the concept of before and after. This means that asking what came before the Big Bang is logically equivalent to asking what exists north of the North Pole, a question that dissolves the moment we examine it carefully because the very framework we are using to construct the question ceases to apply. Yet despite this logical impossibility, our minds continue to rebel against the concept, continuing to generate images and narratives of what might have preceded creation, imagining void-like states or cosmic eggs or infinite potentialities, as though the human imagination possesses some special access to realms that physics tells us are genuinely inaccessible to inquiry. The mechanism behind this persistent confusion is rooted deeply in how our minds evolved to understand causality and time. We exist within time, we experience cause and effect as fundamental features of reality, and our cognitive architecture treats time as a fundamental container within which all events must occur. When we are asked to imagine a state outside of time itself, we paradoxically place it within time conceptually, imagining it as an earlier moment, a previous era, a temporal location that precedes the Big Bang, which is precisely the logical error that generates the paradox in the first place. What is remarkable is not merely that we make this mistake, but that we continue to make it despite repeated explanation, despite understanding the logical contradiction intellectually, despite recognizing that time itself cannot exist before time began, and yet still we find ourselves drawn to contemplate what came before. Still we ask the question, still our minds generate possible answers. Normalizing an inquiry into the logically inaccessible as though it were simply another empirical mystery awaiting future discovery. Perhaps this persistent urge reveals something profound about human consciousness itself, that we are creatures fundamentally shaped by narrative and causality, unable to rest comfortably with true boundaries, compelled by our very nature to ask questions even when the universe itself suggests certain doors were never meant to open. And yet in this very impossibility lies a strange gift. The question itself, unanswerable though it may be, has driven us to develop the mathematics of spacetime, to peer backward through billions of years of cosmic history, to understand that the universe requires no external creator or prior cause because causality itself is woven into its fabric, meaning that our forbidden question, by its very resistance to answer, has illuminated the deepest structures of reality itself. Imagine standing at this very moment, reading these words, aware that the past has already happened and the future has not yet arrived, and in this awareness exists a profound philosophical tension that has troubled physicists and philosophers for centuries. Presentism is the intuitive view that only the present moment exists, that yesterday is genuinely gone and tomorrow has not yet come into being, and that reality consists solely of what is happening right now in this eternal fleeting instant. Eternalism, by contrast, proposes that past, present, and future all exist equally and simultaneously, that all moments in time are equally real, and that the distinction between past, present, and future is merely a subjective human experience rather than an objective feature of reality. When you recall your childhood, presentism suggests you are accessing memories of something that no longer exists anywhere in the universe, while eternalism suggests that your childhood still exists in the temporal landscape, just as distant from your current moment as Los Angeles is distant from New York. The psychological mechanism at work here is that our direct experience of the present moment feels fundamentally different from our experience of memories and anticipations, creating an almost irresistible intuition that only now is real. We feel the presence of the present in a way we do not feel the presence of yesterday, and this emotional and phenomenological distinction creates a powerful bias toward presentism in human consciousness. Yet Einstein's theory of relativity suggests something closer to eternalism, showing that time may be more like a dimension similar to space rather than a river flowing from past to future. Despite having no logical reason to accept presentism as the fundamental nature of reality, despite the mathematical elegance of eternalism and its alignment with relativity theory, humans continue to live as if the present is uniquely real, as if this moment matters in a way no other moment does, and we have normalized this contradiction so thoroughly that we scarcely notice we are living within it. Accepting the paradox of feeling that our now is special, while the physics suggests it is not. Perhaps this explains why we grieve the dead and celebrate birthdays, why we make promises about tomorrow and feel responsible for yesterday. We are creatures who must live presentistically even if the universe may be eternalistic, and this fundamental mismatch between how we experience time and how time may actually exist may be not a bug in human consciousness, but rather an essential feature that allows us to navigate, to care, and to mean something in a cosmos that may not care about our present at all. In this sense, the debate between presentism and eternalism may ultimately be less about discovering which view is metaphysically true and more about recognizing that human meaning-making requires us to live in the present moment, even as physics suggests all moments are equally real. And perhaps this is the deepest wisdom available to us, not to resolve the paradox, but to inhabit it fully. We might say that the mother holding her newborn child is simultaneously participating in eternalism, knowing that this moment will exist forever in the block universe, and presentism, feeling the irreplaceable realness of this singular now, and perhaps she needs both truths to fully understand what it means to love something that will change. Imagine standing at the edge of a vast platform that stretches infinitely behind you into darkness, while before you lies an endless expanse of fog and uncertainty, and you are told that only the ground beneath your feet is real, that everything behind you exists as a completed and unchangeable record, while everything ahead remains unformed and potential, waiting to be born into existence as time carries you forward through the moments. This is the essence of the growing block theory, a conception of time that attempts to reconcile our intuitive experience of a flowing present with the seemingly fixed nature of the past, suggesting that reality itself expands moment by moment as the present advances through what we call the future, leaving behind it an ever-lengthening trail of solidified history. In this model, the past is genuinely real and complete, the present moment is razor-sharp and vivid and absolutely concrete, and the future does not yet exist at all, not even in potential form, but will come into being only as the advancing present reaches it and transforms it into actuality. The psychological appeal of this theory runs deep because it matches our lived experience so perfectly. The felt sense that we inhabit a definite now surrounded by memories we cannot change and possibilities we cannot fully predict, yet the logical consequences become strange and troubling when examined closely. If only the past and present are real, then facts about the future are not yet facts at all, they are mere descriptions of empty space, which means that whether you will finish reading this narration, whether you will fall asleep peacefully, whether the sun will rise tomorrow, these are not yet determined truths, but will only become truths when the growing edge of reality reaches them. The theory preserves human intuition about temporal flow and the reality of the present moment. It explains why we remember the past but cannot predict the future with certainty. Yet it demands we accept that vast swathes of the universe simply do not exist yet, that the present moment is literally the boundary of being itself, constantly expanding outward and creating reality as it goes like the edge of a sphere being inflated from within. What makes this persist as a serious philosophical position, despite its extraordinary demands, is that no observation we can make truly refutes it, for we can only ever experience the present, and within the present, the past always appears fixed and complete, while the future always appears open and undetermined. So the growing block theory manages to feel both radical and inevitable at once. A description of time that seems impossible, until you consider that all other descriptions might be equally impossible in their own hidden ways. Consider that a growing block universe might explain why the laws of physics seem to permit genuine randomness at the quantum level, not because reality is indeterminate, but because those future states have not yet been actualized into existence, and thus there is literally nothing to be determined about them until the present moment sweeps them into the realm of the real and fixes their nature forever. Imagine sitting in a darkened theater where a single beam of light sweeps across the stage, illuminating different areas in sequence, and as you watch this spotlight move, you experience a curious sensation that the light itself is somehow special, that the illuminated region possesses a quality of actuality or presence that the darkness ahead of it does not yet possess, and the darkness behind it has somehow lost. This is the moving spotlight theory of time, a philosophical framework that suggests the present moment is like that beam of light, constantly advancing through the landscape of past and future, constantly revealing what is real and actual while leaving behind what has become determined and finished. In our everyday experience, this metaphor feels intuitively correct because we seem to live always at the edge of becoming, always at a boundary between what has already happened and what might happen next, and the present moment does seem to possess a special status that other moments do not possess. We perceive this spotlight as it moves, we experience ourselves as always being at its center, and we feel that our current moment is somehow more real, more vivid, more actual than the moments that came before or that might come after. Yet when we examine this concept logically, the moving spotlight creates profound problems that seem impossible to solve. If time itself is a static landscape, a block of past and future all equally real and existing simultaneously, then there is no objective fact of which moment is the present moment, no physical mechanism by which the spotlight moves, no explanation for why consciousness seems to always ride along at the boundary of the present, and no clear answer to the question of how fast the spotlight moves or in what units we could even measure such movement. The paradox deepens when we consider that the spotlight metaphor requires time to move, yet time is supposedly the dimension within which movement occurs, creating a circular logic in which time must move through time, which seems to demand a second dimension of time to measure that movement. Despite these logical impossibilities, the moving spotlight remains perhaps the most persistent and natural way that human consciousness frames its experience of temporality, and we continue to believe in its reality so completely that we rarely question whether it might be an illusion generated by our particular form of awareness, a feature of consciousness rather than a feature of the universe itself. Perhaps the most unsettling possibility is that the spotlight's movement is real and immediate to us precisely because we are embedded within time rather than outside it observing it, and that our sense of the present's special status reflects not an objective feature of reality, but rather the structural limits of consciousness itself, which can only process information sequentially and thus experiences time as a moving edge rather than as a static landscape already fully formed. In this view, the spotlight's movement becomes less a mystery of physics and more a mystery of neurology, a question not about how time actually works, but about how minds like ours, bound to sequential processing and linear memory, necessarily construct a sense of presence and immediacy as we move through the continuous stream of experience. Imagine standing on the deck of a ship in ancient Greece, and Aristotle approaches you with a question that will trouble philosophers for more than 2,000 years. He asks whether a sea battle that has not yet occurred is definitely going to happen, or whether it remains genuinely uncertain and open to possibility. The battle is scheduled for tomorrow, yet tomorrow has not arrived, and so we find ourselves suspended in a peculiar logical predicament that seems to tear at the very fabric of how we understand time and destiny. If the sea battle will definitely occur, then today it must already be true that it will occur, and if it is already true today that it will occur, then the battle is not genuinely uncertain, but rather predetermined and fixed, as though written into the structure of reality itself from the beginning of time. Yet if we say the sea battle is genuinely uncertain and might not happen, then no statement we make about it today can be definitely true or false, which means the laws of logic itself seem to break down, for every statement must be either true or false according to the principle of bivalence that underpins rational thought. Aristotle recognized that this paradox emerges from a fundamental confusion about how truth relates to time and causation, and he suggested that statements about future events might not yet possess a definite truth value in the way that statements about the present or past do. The mechanism driving this paradox operates at the intersection of three concepts that we normally treat as separate: the logical principle that every statement is either true or false, the physical understanding that the future does not yet exist, and our intuitive sense that we possess genuine freedom and choice in our actions. When we combine these three ideas simultaneously, they begin to contradict one another, creating a logical knot that cannot be easily untangled. We have somehow normalized this paradox by simply not thinking about it very carefully, by treating the future as though it were already real and determined, while simultaneously acting as though our choices matter and remain genuinely open, and by accepting that logic applies perfectly to future events, even though the future itself is fundamentally different from the past or present in that it does not yet exist in any concrete form. Yet this peculiar blindness serves a purpose. The moment we truly accept that the future remains genuinely open and undetermined, we must also accept that our confidence in prediction, planning, and causal reasoning becomes provisional and fragile, forcing us to live with an uncertainty that our minds instinctively resist. And yet, without this comfortable illusion of a determined future, we would find ourselves paralyzed by the weight of infinite possibilities at every moment, unable to act decisively or plan meaningfully, which is perhaps why Aristotle himself chose to live as though the battle were still genuinely undecided, even while acknowledging the logical problem that suggested otherwise. This tension between logical necessity and human agency remains unresolved even today, surfacing in modern debates about determinism and free will, in the algorithms that claim to predict our choices before we make them, and in our continued insistence on holding people morally responsible for actions that, if the universe is truly deterministic, were already written into the fabric of existence from the moment of the Big Bang. In the 4th century, a Christian theologian named Augustine sat alone in his study, his mind turning over a question that had plagued him for years, a question so simple it seemed almost childish, yet so profound that it had consumed his greatest intellectual efforts. He asked himself, "What is time?" And the moment he tried to answer, the question seemed to dissolve beneath his own examination, like trying to hold water in an open hand. When he thought about the past, he realized it no longer existed, having already passed away into nothingness. When he contemplated the future, he found that it had not yet arrived and therefore did not exist either. And when he attempted to grasp the present moment itself, he discovered that the present was nothing more than an infinitesimally thin boundary between the non-existent past and the non-existent future, a boundary so thin it seemed to have no duration whatsoever and therefore no existence of its own. This was Augustine's restless question, and it emerged from the most basic human experience. The feeling that time is real, that it flows from one moment to the next, that we can measure it and divide it and experience it, and yet when we turn our analytical attention toward it, the very thing we are trying to understand vanishes beneath our scrutiny. The psychological mechanism at work here involves what we might call the paradox of phenomenological certainty, wherein something feels absolutely real in our lived experience, and yet reveals itself to be logically impossible when examined closely. We know that time exists because we remember the past, anticipate the future, and experience the present, and these things feel like immediate facts of consciousness. Yet every attempt to define what time actually is, to locate where it is, to explain how it moves or whether it moves at all, leads us back to Augustine's original perplexity. And perhaps most remarkably, despite centuries of philosophical inquiry, scientific investigation, and psychological study, we continue to live as though time is unquestionably real, marking our calendars, planning our futures, recording our histories, organizing our societies around temporal structures, all while harboring in the background of our minds the nagging awareness that we cannot quite explain what the thing we are measuring actually is. We have normalized this contradiction so thoroughly that we scarcely notice it anymore, moving through our days with the practical certainty that time exists and matters, while simultaneously holding the intellectual recognition that its fundamental nature remains profoundly mysterious. Yet in this very contradiction lies perhaps the deepest insight. That time may not be a thing to be grasped at all, but rather the fundamental condition through which consciousness itself unfolds, the medium in which meaning occurs, and therefore something that can never be fully objectified by a mind that exists only within its flow. Augustine himself seemed to arrive at this insight late in life, suggesting that perhaps the question was never meant to be answered, but rather lived with, that to ask, "What is time?" is already to participate in the very mystery one seeks to understand, and that this participation, this wrestling with the unanswerable, is itself the deepest form of temporal consciousness. Imagine standing in a vast cathedral of theoretical physics, where Isaac Newton once declared that time flows uniformly and independently from everything else in the universe, moving forward like a river that cannot be stopped or altered, existing outside space and independent of observers or events, a true backdrop against which all motion and change are measured. Newton proposed that this absolute time ticks away identically everywhere, whether you are on Earth or in the distant reaches of space, whether you are moving rapidly or standing perfectly still, suggesting that a single universal clock governs all moments with perfect regularity and impartiality. This conception felt intuitively correct to centuries of scientists and philosophers because it matched their everyday experience of time as something measurable, objective, and consistent, something that could be trusted to maintain the same rate regardless of circumstance or perspective. Yet the mechanism underlying this belief reveals something curious about human cognition. We naturally project our subjective experience of sequential moments onto the external world, assuming that our internal sense of time's flow must correspond to an actual external phenomenon operating in the same way, and we tend to trust what feels most obvious rather than what can be rigorously tested. Newton's absolute time persisted as unquestioned truth for more than 2 centuries despite being entirely untested, despite lacking any experimental verification, despite the fact that no one had ever actually measured time across different reference frames to confirm that it truly remained constant. And we normalized this assumption so thoroughly that questioning it seemed almost heretical. Scientists built entire systems of mechanics upon this foundation, calculating trajectories and predicting motions with remarkable accuracy, which only reinforced the sense that absolute time must be real because the mathematics worked so elegantly. Yet what actually occurred was a profound logical inversion. Because our equations assuming absolute time produced useful predictions, we concluded that absolute time itself must exist in nature, when in fact we had merely created a useful fiction, a mathematical convenience that happened to work well enough for objects moving at ordinary speeds through ordinary space. Einstein later demonstrated that time does not flow identically everywhere, that it stretches and compresses depending on velocity and gravitational fields, that simultaneity itself is relative to the observer, and suddenly Newton's absolute time evaporated like morning mist, revealing itself as not a discovery about nature, but rather a projection of human intuition onto reality. Yet even today, in ordinary conversation and in much of classical physics, we continue to speak and think as though Newton was correct, continuing to trust in absolute time not because evidence supports it, but because the habit runs so deep that it requires sustained intellectual effort to think otherwise. Consider a universe in which nothing ever changed, in which no objects moved and no events occurred, yet time somehow continued to pass in perfect, unmeasurable silence. This thought experiment, which the German philosopher Gottfried Wilhelm Leibniz posed centuries ago, reveals something deeply unsettling about our understanding of temporal reality. Leibniz argued that time is not an independent container or absolute substance into which events are placed, but rather time exists only as a relationship between objects and the changes that occur between them. Without change, without the movement of particles or the sequence of events, time itself becomes meaningless and arguably ceases to exist entirely. In our everyday experience, we perceive time as flowing forward because we observe constant transformation in the world around us. Your coffee cools, your body ages, leaves fall from trees, and the position of the sun moves across the sky. These changes create the impression of time's passage, yet Leibniz suggested that time itself is nothing more than the order and relations between these changes. If everything froze in place, if the universe became perfectly still with no alterations whatsoever, then the very concept of time would lose all coherence and reference point. What is remarkable about this perspective is how thoroughly we have naturalized the inverse assumption in modern thinking. We treat time as a fundamental dimension, almost like a river flowing regardless of whether anything changes within it, yet Leibniz's argument persists in contemporary physics and philosophy, particularly in relational approaches to spacetime. We continue to measure time as if it were independent of the events we use to mark it, checking our clocks as though they reveal something about the universe rather than merely recording intervals between observable transformations. The paradox deepens when we recognize that our entire scientific apparatus for understanding reality depends on treating time as real and fundamental. Yet this very apparatus cannot function without observable change, without something actually happening to measure against. We have built civilizations on the assumption that time flows independently, yet the logical foundation for that assumption rests entirely on change and relation, a contradiction we live with so comfortably that we rarely pause to notice it persists. Perhaps the deepest irony is that even our most advanced physics, relativity theory, which Leibniz's relational thinking helped inspire, ultimately confirms that time and space are not independent absolutes, but emerge from the relationships between objects and events, suggesting that what we dismissed as medieval philosophy was actually a glimpse of reality's true structure. Yet even as modern physics validates Leibniz's insight, we remain trapped in the habits of absolute time, unable to fully internalize that the universe's temporal structure is woven from the very changes we observe within it, and that asking what time does when nothing changes is like asking what music exists in silence. The silence itself becomes the answer. Time is not a stage upon which change performs, but rather the performance itself, the very act of transformation that constitutes temporal existence. In this view, to ask whether time exists without change is to commit a category error, mistaking a description of relations for an independent entity that could somehow stand apart from them. Consider the moment you become aware of your own thoughts without observing them through any external means, the peculiar sensation of knowing what you are thinking simply by the fact of thinking it, a phenomenon that Immanuel Kant called the inner sense, that mysterious faculty by which the mind apprehends itself across time. When you reflect on your own mental states, you are not looking at yourself through a mirror or listening to your voice through someone else's ears. You are somehow directly aware of the contents of your consciousness as they unfold. Yet this direct awareness contains a fundamental paradox that has troubled philosophers for centuries. Kant observed that in order for you to know anything about your own inner life, that inner life must first be arranged in time, must be presented to you as a temporal sequence of moments and experiences, which means that time itself becomes the form through which your mind knows itself, the container within which all self-knowledge must occur. The strange part emerges when you realize that you cannot step outside this temporal framework to observe it objectively. You cannot compare your experience of time with time as it actually is, because any such comparison would itself require the use of time itself. Your inner sense is therefore always bound by time, always experiencing the world and yourself through this lens of duration and succession, yet you have no access to what time might be independent of this inner sensing. You know yourself only as you appear to yourself in time, not as you are in yourself beyond time, and this creates a recursive loop where the very tool you use to understand your own nature is the thing you cannot examine apart from itself. We move through our days experiencing this paradox as completely natural, taking for granted that we know our own minds, that our sense of duration and continuity accurately reflects something real about both ourselves and the world, without recognizing that the very structure of our self-knowledge might be constructed rather than discovered, imposed by the architecture of perception rather than revealed by some transparent window into truth. Yet when you sit in silence and try to observe this very process, to catch yourself in the act of thinking, the act of observation itself becomes a new thought, pushing the original one into the past, and you are left chasing your own mind like a dog pursuing its tail, forever one step behind the experience you seek to examine. This is perhaps why Kant insisted that the self we know through inner sense is not the true self, but only the self as it appears filtered through time's distorting lens, a phenomenal self perpetually constituted by the very act of self-examination, never the noumenal self that remains forever beyond the reach of introspection. And yet this distinction between the phenomenal self we observe and the noumenal self beyond observation is not a limitation to despair over, but rather the very condition that makes moral freedom possible. For if we were entirely transparent to ourselves, entirely determined by the temporal sequence of causes we can observe, we would be nothing more than mechanisms unfolding according to law. Whereas the hidden depths beyond our inner sense may harbor the spontaneity and autonomy that genuine responsibility requires. Consider the experience of listening to a piece of music, where you hear a melody unfold across several seconds and somehow perceive it as a single, unified event rather than a collection of disconnected moments. And this phenomenon is what philosophers call the specious present, a psychological window of time that feels like the now even, though it actually encompasses a measurable duration of past moments that your consciousness weaves together into a coherent experience. When you listen to a song, your brain does not wait for a complete phrase to end before processing what you are hearing. Instead, it holds the recent past in a kind of active memory, blending those fading notes with the sounds arriving in the current instant, creating the illusion of a single, extended present moment rather than the strict, infinitesimal point that physics suggests the present should be. This temporal thickness is not merely an artifact of how we perceive music, but extends throughout all of human experience. When you watch someone throw a ball, your brain retains the trajectory from the previous fraction of a second and combines it with what your eyes see now, allowing you to perceive motion as a continuous phenomenon rather than as a series of frozen still frames. The specious present typically lasts anywhere from half a second to several seconds depending on the type of experience, yet we remain largely unaware that we are constantly living in this extended window rather than in a razor-thin point of absolute now. And this psychological necessity arises because consciousness itself requires duration to exist. A mind that could only access the truly infinitesimal present moment would be unable to perceive causality, motion, melody, or meaning in any form whatsoever. What makes this paradox so profound is that our subjective experience of time seems to require this temporal thickness, yet neuroscience and physics offer no comfortable explanation for how a spread-out duration can genuinely be perceived as present, and we have so thoroughly normalized this contradiction that we rarely question whether the present moment we feel ourselves living in is actually a kind of beautiful deception that our brains construct to make existence comprehensible. Or whether there is something about consciousness itself that genuinely redefines what presence means, transforming an objective physical duration into something that feels like now. Perhaps the deepest implication is that the self experiencing this specious present is not a passive observer, but an active architect of time itself, constantly negotiating between the physical world's indifference to our perception and consciousness's stubborn insistence on weaving duration into meaning, suggesting that the present moment we inhabit is less discovered than it is perpetually invented. And so when you catch yourself wondering whether you are truly present in your own life, you might recognize that presence itself is not a state to achieve, but a continuous creative act, one that your consciousness performs millions of times each day, each time deciding which threads of past sensation to weave into the fabric of now, each time choosing what duration of experience deserves to be called real. Imagine yourself in a moment of sudden alertness, perhaps when you glance at a clock or when something startling occurs in your peripheral vision, and in that instant, time seems to stretch, elongating the present moment into something that feels considerably longer than it actually was. This phenomenon is called chronostasis, and it represents one of the most peculiar distortions of temporal perception that occurs within the human mind. When you shift your gaze from one object to another, there exists a brief period during which your eyes are moving, but your brain is not receiving visual information, a gap called a saccade, yet you perceive no discontinuity in your visual experience. Instead, your brain appears to backdate the moment when your eyes land on the new target, creating the subjective sensation that you have been looking at that location for slightly longer than you actually have. This temporal illusion serves as evidence that the present moment, that supposedly fixed point we experience as now, is actually a construction rather than a reflection of objective reality. The mechanism underlying chronostasis appears to involve your brain's attempt to stitch together a seamless experience of the world by retroactively adjusting your perception of when events occurred, filling in gaps and creating continuity where none objectively exists. When you experience a sudden event, your brain seems to extend the duration of that moment backward in time, making it feel as though you saw it coming, even though the actual duration of perception was far briefer. This temporal backfilling happens without your awareness or consent, and it demonstrates that your subjective experience of time is fundamentally unreliable, constantly being edited by neural processes operating beneath the threshold of consciousness. Despite understanding the neurological basis of chronostasis through scientific study, we continue to trust our intuitive sense of when things happen, accepting our brain's revision of temporal reality as though it were objective truth. We live within these constructed moments without recognizing their artificial nature, never quite accounting for the fact that the present moment we experience is always slightly out of sync with what is actually occurring in the world around us. This lag between reality and perception becomes even more pronounced in moments of genuine danger. When you swerve to avoid a collision or flinch from an unexpected threat, your brain has already initiated the response before conscious awareness catches up, yet you experience it as a deliberate choice made in real time, a temporal narrative that comforts us with the illusion of agency. In this way, chronostasis becomes not merely a quirk of neurology, but a fundamental feature of consciousness itself. A reminder that the self experiencing this moment is always trailing behind reality, constructing a version of events that feels immediate and authentic even as it reconstructs the past with each passing second. We are, in essence, time travelers moving perpetually backward through our own lives, narrating events that have already concluded while believing ourselves to be living them as they unfold. Imagine yourself sitting in a room with 9 other people, all of whom turn their heads to look at a blank wall at precisely the same moment, their eyes fixed on absolutely nothing, their attention focused entirely on empty space that contains no stimulus whatsoever. And yet, despite knowing with complete certainty that there is nothing there to see, you feel an almost irresistible compulsion to look as well. To turn your own head and gaze at the same vacant expanse, because the sheer unanimity of their attention has somehow created a phantom presence, a psychological weight that makes you question your own perception of reality. This phenomenon, known as the Oddball Effect, or sometimes called the cocktail party problem when applied to auditory perception, reveals something profoundly strange about how our brains process information and attention within social contexts, operating under mechanisms that seem designed to override our individual rational assessment in favor of collective observation. The mechanism beneath this effect is rooted in our evolutionary heritage as social creatures who survived by paying attention to what others paid attention to. Because historically, if 8 members of your tribe suddenly became focused on something, the likelihood that you were missing critical information about danger or opportunity was extraordinarily high, and natural selection favored the brains that prioritized social cues over solitary reasoning. Our attention systems are not independent validators of reality, but rather deeply embedded in social prediction networks that constantly ask the question of what should I be attending to based on what those around me are attending to, creating a kind of cognitive gravity well around the focus points of other people. And this remains true even when we consciously understand that the stimulus they are observing does not actually exist, or that their attention is being directed by some experimental protocol or social game. What makes the oddball effect particularly paradoxical in our modern context is that we have become increasingly aware of these mechanisms. We have read about them in popular psychology books and seen them demonstrated in viral videos. And yet the knowledge of why we do this does nothing to diminish our susceptibility to the effect itself, suggesting that conscious understanding operates in an entirely different neural system from the automatic attention-following systems that evolved over millions of years, and that these ancient systems continue to exert their influence over our perception of reality regardless of what our rational mind knows to be true. Perhaps the deepest irony is that even now, reading this explanation of the oddball effect, you may find yourself unconsciously primed to experience it the next time you encounter a group unified in their attention, your awareness of the mechanism providing no immunity whatsoever, merely the added layer of self-consciousness that comes from watching yourself fall prey to the very psychological forces you now understand. And perhaps that self-consciousness itself becomes another form of the oddball effect. We become hyper-aware of our own susceptibility, which paradoxically makes us even more attentive to the shared focus of others, transforming our knowledge into yet another layer of social coordination that binds us to the collective gaze we meant to escape.